A very good afternoon to one and all present here. On behalf of the organizing committee, I warmly welcome you all to the 6th day of AICTE Atal-sponsored 6 days online faculty development program. In the previous sessions, we explored data acquisition, communication, edge processing, and automation in IoT systems. Today's topic focuses on how IoT data is seamlessly integrated with cloud platforms and transformed into meaningful insights through effective data visualization. This session will help participants understand cloud data storage, real-time data processing, and visualization techniques that support informed decision-making in IoT applications. We look forward to an insightful and interactive session that bridges IoT system with cloud intelligence. With this, let us begin today's session. Now it's time to start our session 11. Let me introduce our today's resource person. It's our pleasure to introduce esteemed resource person, Dr. Ramya, Associate Professor at Sri Krishna College of Engineering and Technology, Coimbatore. Dr. Ramya has strong academic and research expertise in the areas of cloud computing, data analytics, and data visualization. She has been actively involved in teaching, research, and guiding students in emerging technologies with a focus on applying cloud-based solutions for real-world data-driven applications. In today's session, she will be delivering a talk on cloud integration and data visualization, a highly relevant topic that bridges a scalable cloud platforms with effective data interpretation and decision-making. We are confident that her insights and academic experience will greatly benefit all the participants of this Atal Faculty Development Program. Let us extend a warm welcome to Dr. Ramya ma'am to begin the session. Welcome you, ma'am.
Good afternoon, ma'am. Thank you for your introduction.
Good afternoon, ma'am.
Now, ma'am, is it visible on,
Yes,
ma'am?
ma'am, it is visible.
Audible also, okay, ma'am.
Ma'am, yes, ma'am.
Volume also.
Okay, ma'am, okay.
Yes.
Everything
Good afternoon
okay.
to one and all. So, myself, Ramya, Associate Professor from AC Department, and now I am working at Sri Krishna College of Engineering and Technology, Coimbatore. So, today we are going to see the presentation on the topic cloud integration and data visualization. So for IoT. So I hope that you all came to know that what is IoT and why you are using this IoT and what is the scope of IoT, the research field and all like that you have came across. Now we are going to see how that information, that is how we are transferring the information through the cloud, and then how we are retrieving the data, and then how we are visualizing the data in the form of various charts. That is data visualization. Okay. So first, this is my agenda. What is cloud? Type of cloud services, type of cloud deployment, then advantages of cloud, real-time examples of cloud, what is cloud integration, cloud-based IoT platforms, how to link the cloud platform with Arduino, then cloud-based IoT platform, why cloud integration is important, data sources in cloud system, data pipeline, then what is data visualization and its types, then cloud-based visualization tools. So today we are going to learn this and we are going to see what means is the data flow. What is the source That is from where we are getting the data, then what we are transmitting, then how we are transmitting, then how we are visualizing. That is the ultimate aim of this session. So first I'm gathering information through the sensor. Then from the sensor, that information will be processed with the support of Arduino. That is Arduino, Nano, whatever may be. So here, for example, I have assumed it is Arduino. Then that information will be given to the cloud through the Wi-Fi. Then there is MQTT. That is here I have given that. It is MQTT allows the IoT devices, it may be Arduino, ESP32 or sensor. Directly from the sensor also we are gathering to send and receive the information to the cloud platform through the Things board. So directly we can't send the information to the cloud platform. So we need some intermediator. So that kind of intermediator here used is the MQTT. That is why we are using this. It requires only little bandwidth, also little power consumption. Okay, 2 seconds. Ma'am, whether it is okay now?
Yes, ma'am.
Okay.
Okay.
Then next, so by using those intermediator and all, the information will reach us the Things board. This is the cloud platform. This is the Things board cloud. It is nothing but a name of a platform. So many platforms are there. We shall see all those things. So here it is one of the platform. Then it gathers the information and it reaches the other end user. That is the end user in the form of a dashboard. Here this is your output environment. For example, in the input side, it accepts the information in the form of a temperature, humidity, and all names that will be visualized by using any one of the chart. It may be a pie chart or bar chart. Based upon our wish, we may change. So that kind of availability, that is menus are available in the Things mode. So at the end, that is if the end user may be a customer or maybe a researcher, whatever may be, but based on their wish, they can choose the choose the chart to visualize it. Okay, so if it is in the form of a chart, means when compared to the bar chart, that is when compared to the tables and all, the bar chart or any form of chart will convey more information by visualizing itself than that one. So we should prefer the dashboard. So that kind of facilities are available in the Things board. So this is the main object. This is the main criteria. That is the main data flow. So conceptual architecture, here data source. Data source means we are collecting the data from the source. We gather the information. That information is available in the cloud. That is the cloud storage. MQTT we saw, no? By using that, we are transferring the information to the cloud. There we are processing. Directly, we can't visualize the information as it is. If we are sending the data, means we are visualizing. But within that, so many things are happening. So that is called as the cloud storage. So their storage will happening. That is done in the integration layer. Integration means it will combine from one environment to the other environment. Then afterwards, it will perform the processing and it will give the statistics that whether it is whether it belongs to one category, like that it will categorize. Then visualization. Then after that, after categorization, that is based upon the user wish, it will convert that. It is in the form of a table. That is like that only cloud will accept the information. So it will perform the operation and convert it to a record form. So if I want to convert that table format into a bar chart, means so inner processing should be done. After that, we are visualizing the output. Then visualization using any one of the tool. Here the dashboard, in the Things board itself, visualization is available. If you have without any Wi-Fi or without any integration, if you want to visualize also, so many visualization tools are available. Then finally, we are getting the information in the dashboard. Dashboard is nothing but a web page. In that page, we can see the output in the form of a chart. So this is a cloud statistics, then PBI desktop. The meaning of this PBI desktop is called as Power. That is Power BI desktop. Power BI, it is one of the data visualization tool. There we can visualize the output. So for what? that is to visualize, to interpret the information about the data set, or you can visual information or give the information as in the form of a report. For example, if any data set contain any patient's information, means it will categorize what kind of tumor it is. Like that, it will categorize. Or it may be an iris data set, means Setosa virginica. Like that, it will categorize how many count will be there. Or in the case of a supermarket, means how many things will be there, how many furnitures will be there, how many discount items are there. Like that, that kind of information will get categorized, and we can visualize like this. We shall see one by one. So that kind of information is available here. By using this itself, we can visualize that. That is how many discount items are available in the, that is the items with the discounts are available in the supermarket. Like that, we can see. So those kind of information will be either you can transmit it directly from the data set, also you can visualize, or through the cloud platform also you can visualize. That is company real-time data applications. If you want to need information as a real time, we are in one place and we are at that is the supermarket at the one place, and if you want to visualize what is happening within that is any real-time information from remote end also we can see by using this. So now see, we are telling that cloud and all. One second. Ma'am, is it okay? Am I audible? Hello? Am I audible? Anyone is here? Please tell me, anyone. Am I audible? Okay. Thank you for your response. So we used to use the word that cloud. So now we are going to see what is cloud. Cloud means it is just a path through which the information can be receiving. It is a path through which the information will be sent. That is a way of using the resource over the internet instead of owning and maintaining the physical hardware like servers or storage or software. It is a free end, so it doesn't need any hardware equipment and all. So instead of purchasing any components like that is a server and all or software and all, we are using the information over the internet. Through the wireless media, we are transmitting the information and maintaining the physical hardware. So these servers and all needed, but we are transmitting the information at the low cost. Then instead of saving files or running software on your local computer, we are transmitting the information in the form of a wireless. It is data is stored in the cloud data center. Their servers are available. Here it is given that the applications are run on the remote servers. You access everything via web browser or web app. So this is a structure how the information is passing. Here first one is the front end. In the front end, client will be there. Client is the user. So the client will pass the information to the internet. From that internet, the information will be given to the backend. Backend storage is nothing but there we have a cloud platform. There the information will get stored. So it is having a capacity to store a huge amount of information. If the user means they can retrieve the information from there. So transmission and reception is also possible. From the user end, the information will be given to the backend. So this backend is we can't able to visualize. Then from the backend, if you want the need for the data further means from the server we can gather that information, that is stored content. So the next one is type of cloud services. So type of cloud services, we shall start from the IaaS. The meaning is that infrastructure as a service. Infrastructure as a service means, so first we are transmitting the information through the cloud. Through the cloud means first the information will reach the server. So virtual servers and storage media is there. So it is nothing but a Google compute engine. There only, in the server only, the information, that is the decompression and decoding, all those things will be happening there. The next one is platform as a service, that is PaaS. It is used to develop and deploy the application is by using this Azure app services, and it is nothing but a platform. Previously I said I use the word called a things board, no? Like that one Azure app service is there. So it gathers that information, that is a cloud shared content. So this is a platform where it will perform the processing. Then that information will be given, transmitted over the internet and converted into a suitable form, that is visualized one. So here this is a cloud service model. So this is first one is IaaS. IaaS, I said, no, from the user it is collecting the data. That is from here the decryption, everything will happen. Then that information will be given to the things board or Azure software. Then that will be given to the, that is converted, that is our processing will be done and it is converted into a suitable form that is needed for the user. That is the application stack. The next here, type deployment, cloud deployment is so many clouds will be there. Here first one is public, private as well as the hybrid cloud. So public cloud and all. So the public cloud include Azure, Google Cloud. Google and all we all are using, no, in all our day-to-day life. We are transmitting the information in the form of through the Google, Gmail. Like that only we are using that one. So it is called as a public cloud. In addition to that, we have Azure and AWS cloud. The next one is private cloud. Here it is dedicated to one organization. So it is nothing but a private sector. So if it is a private institution, means it may be a university or any college or any private schools and all. It is they purchased a certain amount of the frequencies, that is a spectrum. So that belongs to one particular organization only. So no other parties should not use that one. So that is called as a private cloud. The last one is called as hybrid cloud. It includes both the that is both private as well as public cloud. So combination of both. Then why we are using cloud? So you all know. So cloud means it is nothing but it won't occupy a lot of space. Maintenance also will be less. So no need to buy the hardware. So hardware we are transmitting through the air only. So no need to buy hardware. Then scalable, increase or decrease the resources easily. So we can transmit the information as much as possible. Cost wise also pay only for what you use. I said no, private and public is there, no. So private cloud and public cloud is there. If the private organization is need to use that certain platform, means they need to purchase that particular spectrum and all. So that is a cost effective only. If you want a limited one, means for that only we shall pay. Then accessible from anywhere through the cloud. We can all these cases I said earlier. By using the data visualization tool, we can visualize the output wherever. Then high reliability and backup also. Then next, these all are the cloud providers, the infrastructure IaaS. I said no, IaaS, PaaS and SaaS. For each one service set and service providers are there. For IaaS means I said no, the information will be gathered from the cloud. So first that cloud information will be gathered with the support of Amazon, then Grid, then Sun Microsystems, then platform as a service, Google. So platform, that is a this one also I said that Google will act as a platform. That is a major platform. All are using this Google platform only. Then Azure, Windows Azure, Amazon, then Joinet, then software as a service, SaaS. For that, Zoho, then Microsoft Office Live. So these all are the cloud providers. Then private versus public. We know that public means anyone can use. Private means only limited. So hybrid means it includes all the things. So hybrid cloud choices. Cloud choices may be private, public, or hybrid. So if it is the public means you all know that anyone can use it. So shared information will be there. If you want means you need to use that one. Otherwise you can leave as it is. Then the next one is private. It should be used by the limited organization only. So online premises and external premises, initiative investment is needed. If you want to use a limited resource that is needed for a particular institution means for that they need to pay. So capital investment is needed and cloud setup within the organizer's data center. So the server and everything is available for that one. Then control on security and audit, limited on demand scaling, then based on basic virtualization. Then externally hosted private cloud in the sense exclusive, but hosted by a third party. So institution and all. So external hosted and the online premise will be there. Then limited on demand scaling. This also based on the demand only they are using. Expensive. It is more expensive than the public cloud. Then cheaper than private one. This online premise, when compared to this one, it will be less. Then hybrid, we know that it is a combination of both. Then real-time examples of the cloud, Google Drive, Netflix, WhatsApp, then online banking system. These all are the examples of cloud. So in the cloud, we can store a number of information. The Google, we are transmitting the information. That information will be saved in the cloud. If we want means, again, we are retrieving the data from there only. So like that, nowadays, same as our Google, we are using the WhatsApp also. So it also same thing. Then Netflix streaming, then online banking system. The online banking transaction and all will be done using this only, cloud transformation. So now we saw what is cloud, what are the types of cloud and all. Now how we are integrating this cloud information into the cloud online platform. So thing is that here we are connecting different application system and data sources via the cloud. You all know that we are gathering information from the output environment and transmitting over the cloud. So enable data between online premises and cloud platform. If you want means you may use that one, or a online premise and a cloud platform will be there. Based upon the application, you may choose. Then use APIs, ETL tools, we are transmitting the information. We are transmitting also, the thing is that we should transmit the information as a real time. Then only it will be considered as a best one or a efficient one. Then cloud in relation to the IoT. How we are relating the cloud information with our IoT. IoT means you all know that Internet of Things. So here Internet of Things means it will gather here in the Internet of Things system. It will act as a platform. Act as a platform in the sense it will act as a pathway to transmit the information which are gathered from the IoT sensor. Then it is sent and it is to be processed. Previously we saw no, it will be stored and processed and analyzed. See, the IoT devices may be a sensor and actuators. So sensor in the sense you may gather any real-time information means if you are sitting in a room means if you want to monitor the current temperature of a room, humidity and pressure and all, those things and all have been monitored using the sensor. So that information, for example, if I am at one block and I need to know the room temperature of the nearby block means there I need to place the sensor. Then I need to monitor at anywhere. So the temperature of that particular room can also be monitored. So based on that, the AC condition or the lighting effects has been either increased or reduced. So that kind of real-time operation has to be done through this cloud platform. So that for that, if that operation is needed, means that IoT devices is needed at all the rooms. So that information will be gathered, then it will be stored and it is transmitted over the cloud. Then that cloud will passes that information with the support of servers or any software center. Then information will be reaches the cloud platform. I said no, information will be gathered with the support of the sensor. Then that sensor processing will be done with the support of Arduino. Here I have included Arduino Uno. So Arduino Uno, Arduino Nano, whatever may be Raspberry Pi, whatever hardware you may use. So here it is an example of the Arduino platform. Here you have a serial monitor. Here only the real-time temperature or pressure will get displayed. So this plays an important role. So this information alone will be transmitted to the cloud platform through the cloud. So if we are using any things board and all, means they need some input. That kind of input will be gathered from here only. So by using the sensor, we gathered the information. Here they read and print the nitrogen level. Nitrogen level for this program corresponds to the nitrogen level of a room. So the nitrogen level, current nitrogen level will be displayed here. So that information will be given to the other end. If you want to monitor humidity and the temperature, means we should go for DHT sensor. So that kind of coding you should done here. So the current temperature, humidity and all will get displayed here. That information will passes to the other end. That is the things board or your cloud platform through this. Okay. So this one acts as an input sensor. By using the sensor, it gathered the information and passes through the cloud. So how to link the cloud platform with the Arduino Uno? So now we know what Arduino Uno will do. It will give the current information, the support of the sensor. So first you need to create the device in the things board by using this here. This is the link. So by using things board, and if you type things board, means in the system, in the Google, you just type things board, then one web page will come. There you need to click devices, then add devices. In that device name, you should use Arduino device. You may use Arduino, Arduino, whatever may be, it is your wish. So then copy access token. Access token means there one number will come. You need to copy those one. So that one you need to place it in the coding also. Here also you need to place that coding. Then prepare IDE. Then prepared IDE means in the coding you should access. You should add that code. Then only it will link the Arduino information with your things board. In the things board also you need to link the Arduino information. If we are doing the information at both the end, means it will gather the information from one end to the other end. So if I include the tokens, if I want to link Arduino with the things board, means you need to include the token. Include the token at the input end as the output end. So in the Arduino, you should add the library. That is the client for MQTT. If it is an ESP232 means Wi-Fi H, and ESP82 the 66 means Wi-Fi.H. You need to include all those libraries within the Arduino. Then only you can able to link your Arduino with your platform. So LED status also we can visualize. So in the previous example, I have given the nitrogen value. Temperature also you can monitor with the support of this one. Here this is called as a program. Here this is your Wi-Fi.H, subclient.h and all you need to. These all are the library files. After installation, you should include this one. Otherwise, these two lines will come as an error. Then here your Wi-Fi name. Your Wi-Fi name means here this is my Wi-Fi. Here SKCT_stop. So in your system, SSID, that is ID name will come. That ID alone you need to copy, place it here. Then password will also be there. That password also you should include. So after inclusion, so it will. So the meaning is that why I am using this one. By using this Wi-Fi and the password, the information will be passed to will send to the things board. Here you should include the token. Here you should add the token. That is the token will be is available in the things board. That things board token will be pasted here. If you are doing like that, means the information directly that is present in the Arduino, will get linked with your things board. That's it. So create dashboard in the things board. Here it will create a new dashboard. There you will get the information in the web page. You will be getting the current temperature, pressure, and all. So here this dashboard displays real output. So if my temperature is 25, means that temperature will get displayed. You may, based on your wish, it may display. If you want the information in the form of a table, means it will display like that. Either in the form of a bar chart, means like that. That is at various time instant it will display. At 12 o'clock, what is the temperature? At 12:05, what is the temperature? Like that, it will get visualized. So you can monitor from anywhere. So it is just a linking from one end to the other end with the support of. If you want to link ThinkSboard, means you need to install library files in the Arduino. Also, you need to copy the token that is present in ThinkSboard. That's enough. Then cloud-based IoT platform. So previously I said no ThinkSboard. This is a ThinkSboard. So I hope that all knows about the ThinkSboard. Like that, though like that kind of platform. So many platforms are available. AWS IoT Cap, then Microsoft Azure, Google Cloud, then IBM Watson, ThinkSpeak, ThinkSboard, Blink, and Node-RED. Here, this is a AWS IoT Cap platform. So I said no, we can visualize the temperature, humidity in the form of a graph. So here, this indoor air quality, then battery voltage, temperature, humidity, and all you can visualize like this. In the form of a spike chart also you can visualize. Whatever may be. So in the AWS IoT Cap, their dashboard will be like this. Then if it is in the case of a Microsoft Azure IoT Hub, this is the thing. So in all the platform, the concept remains the same. If you want to change anything, that is, you can change the colors or also. Then here x-axis, the y-axis scale is also there. But we all know, we came across how to draw the bar chart and pie chart, bar chart. But in the case of PowerPoint, then or it may be a MATLAB or it may be a Python, or it may be any word file, and all we can able to draw the chart. So in addition to that, so many facilities are available in this kind of visualization tools. So this is the ThinkSboard platform. It is most user friendly one. I gave the explanation only for ThinkSboard only. Here this is here like this only it is giving. So if the temperature, right, the current goes on 15, means automatically it will get reduced. So like that, the fluctuations will be there at each and every time instance. Real-time values will be viewed here. So if the Wi-Fi facility is well and good, means we can visualize it without any interruption. So this is about the ThinkSpeak, scatter plot, spike, as well as the bar chart is available. This tells about the temperature, then a histogram of the pressure, then TH means temperature as well as humidity, TH. For temperature and humidity, we should use the DHT sensor. Then this is about the Blink platform. Here they have shown the output for the plant health monitoring. Plant health means we need to monitor the pressure and the temperature, moisture of your plant. Then we need to place that sensor at the root side or at the plant. By using that, we can visualize it based upon the soil moisture content. We can either increase or reduce the temperature or reduce the water level. So the next one is the Node-RED. So this is the next type of the chart. Here they have used the donut chart. The name of this one is called as the donut chart. So next we shall see where does the term cloud came from. This cloud means it is used. That is, we know that by using the cloud, we can transmit the information from one end to another. So internet is a foundation for the cloud. So basic thing is internet only. With the support of the internet only, the information will be passing to the cloud. There the information will be stored. Then if you want, means we can gather the information from there. So for those things, for those kind of thing, we need to pay. We all know that in the Google also limited storage is there. If you want to use it beyond that one, means we need to pay. Then only we can use. Otherwise, our data will get lost. Previous data or new data will get lost. So those kind of that is just an example. So payment, that is a paid version is this one. Limited access only will be there. If you want to use, means based on the demand you should pay. So next we are going to see why cloud integration is very, very important. That is previously I said no, visualization plays a major role. Instead of seeing the information in the form of a numerical one, it tells more information that one. By visualizing itself, we can say when compared to the previous hour, how the pressure is varying, how the temperature is there. Like that, we can take the immediate action. So it is considered as an efficient one. So cloud integration plays an important role in real-time any monitoring operation. So centralized data access, it is scalable and flexible one, reduced cost. When compared to other, if we are going for monitoring any wired operation, means there is a need of a space, a lot of space, and maintenance cost and storage equipment will be more. Memory requirement is also high when compared to this cloud. So it is considered as a flexible one. It support analytics and AI workloads. Then without that is the thing is that without any human intervention, it will do all the processing. If we just give all the tokens or ID, password and all, means just we are transmitting the information. There is no need of any courier or any human service and all. So it is considered as a human-free operation. Then next one is called as the data source in the cloud. So data sources in the cloud environment or the SQL. In the Power BI and all, they are using SQL. Then IoT devices and the sensors, these are the information that are needed to gather information from the output environment. Then that information will be given to the Arduino for further processing. Then enterprise application include ERP and CRM, then files, logs, and web data. These all are the information, or these information also we can transmit. Either in the form of an Excel sheet, or in the form of an Excel sheet also you can transmit. Either a single data or numerous data or image, you can transmit. So this is the data pipelines. Here we are collecting the data, then clean and process data. Clean and process means if any noise exists, means we need to remove that one. So if it is in the case of an image and all, that kind of operation, that pre-processing will done here. Then store the data information in the data warehouse or data lake. Then can be batch or real time. It can transmit the information as a streamline, live streaming. So pipeline in the sense how we are transmitting. This is a path. This is a track. This is the track where we are transmitting the information. First, what we want to do, then what are the processing we should do, how to, and then how to store the data and how we are transmitting the information. That streaming will be done through the data visualization. Then data visualization, how live streaming will be done, I will explain to you, and will tell you how to do that, create the dashboard also. The next one is called as data visualization. Yes, any doubts till this? Anybody have doubt till this? This is about the cloud integration part. Next, we shall move to the data visualization. Any doubts so far? Excuse me, am I audible?
Yes, ma'am, you're audible. You're audible, ma'am. Yes, ma'am. Yes, ma'am.
Shall we proceed to the next one? Till now,
yes,
I completed the cloud integration part. Any doubts? Yes, I hope that you all can understand. The next one is data visualization. So data visualization means, I said no, it is, you can visualize the output in the form of charts. That is the graphical representation of the data. It helps in understanding the patterns, or a pattern in the sense of how it is increasing either in the decreasing mode or increasing mode. Like that, we can visualize. Based on that, we can make a decision. That is a support decision making. The next uses is charts, dashboards, and reports. I will explain you what is dashboard and reports and all. So this is about the data visualization. So in data visualization, so many online platforms are available. Most familiar one is this Tableau and Power BI and all. So here, these are the type of visualization. Beyond this also, so many charts are available. So these all are the well-known chart by everyone. But in addition to this, so many charts are available. Now I am going to explain you how we can able to work in the Tableau. So for Tableau and all, just you type Tableau in the online platform. Can you visualize the Tableau? Can you see the Tableau public book 4? So 1 second. Yes. Now is it okay?
Yes, ma'am.
This is a Tableau worksheet. Here, just to type Tableau in the online. So there you can download the Tableau software. So here it is, I think it is supportive only for 1 month. After 1 month, you should, if you want to use means you shall go for some login. That is, if you are using one mail ID means in the next time you should use next mail ID. Then only you can use, otherwise you should go for the paid version. So I'm going a simple chart. After that, so many charts are available. Just you shall, we shall see a few charts. So here in the left side, you have the parameters. These are called as features. So if you are considering any data set, means certain inputs will be there. That inputs are considered as the features. So here in this, this is called as a supermarket information, superstore data set. It is a data set that is present within the Tableau itself. You may also upload your data set. In the main page, they ask you to upload the data set. If you click that one, means it will ask you to upload your data set. So it's just by clicking itself, it will that data set will come in the left side. Here I am going to explain how to work with this Tableau. So first I am going to transfer, just drag and drop only. Category here means in the column. Then here the column means column in the sense what are the things present in that category means furniture, office supplies, as well as the technology. If you want to maximize it also, it will get maximized. So that kind of facility is available here. So the next one is, if I want to view the category with respect to the discount. So whether a discount is available for that particular item or not. Like that, if I am going to drag and drop it here means for this one, it will visualize the output like this. So here, you see, for the furniture, this much of discount is there. If I am keeping the cursor like this means we can visualize it. Then if it is an office means the category will be like this. If you want to view the number for that one means you should include mark label. Mark label always show like that also you may include. So for that one, this much, this is the amount. So these kind of facilities are there. So automatically in the normal thing and all, we need to include X label, Y label and all. So just drag and drop means we can visualize the output easier. So for example, in my data set, if I am having a patient name, patient ID, like that is there means for that patient ID, what is the condition? Like that also we can visualize based upon the user information. You can create the table. So here in this sheet, you can change the file name also. The next thing is that, are you following? Shall I explain one more example?
Yes, ma'am. Go ahead.
So just next one is, yes?
Yes, ma'am. Go ahead, ma'am. Go ahead.
Okay, okay. Then for that order ID, I can give. So ID means so many IDs will be there. So I'm going dragging. That is a ship data. Why I can't able to drag that ID in the sense, ID means, for example, in the data set, if it contain, for example, in 1 month, some 1,000 customers have gone there, means that 1,000 IDs will be there. So I can't able to give the information as it is. So ship date, then order date also can include. So order date. So here you see, here it is a furniture. What is the purchase? That is how much cost or how much, like that we can visualize. Here the furniture, how much sale that happened in the year 2014, 2015, 16, 17, 18. Like that it is given. So 14 lessons, 14 alone is there. 14, 15 means 14, 15 academic year is there. 16 means 15, 16. Like that it goes on. So like that the office supplies as well as the technologies will be there. Then next, in the row information, here also you have, for these all are the features. For these features and all, you can check what is the profit and what is the sale and what is the discount that is happening. Like that you can see. Then for this one, how much sale happened in that for that particular category. Like that also we can visualize. Here it is in the form of a spike, or you may change. If you want to change this one also, you can have the remove option. Here you may include a region also, at which area this is happening, or discount and profit like that also you can see. So if you want to convert this chart into a bar chart, means just you click this one. So in the marks part and all, you have this option. Then if you want area, means area chart will come. Here this area under the curve, like that will come. So if you want a square chart, means that is the spike, at the spike area only the square will come. If you want to change the color, means these kind of options you may use. Then if you want to change the size, means either increase or you may reduce. Like that options are available. Then labeling, previously I marked each bar by bar, I marked. Here you have the option that is show label marks, means each circle or each square it will get displayed. So those kind of things are available. So the next one is line chart. So line chart is there, means this one part will get enabled. So here you see, for all case one get enabled. Here for this alone it will get enabled. For example, if I am choosing the bar chart, means this kind of option got disabled. So if I am going for line chart, means it will get automatically enabled. There you may choose the line pattern also. So dotted one, then choose. So here you see dashed lines will be coming. So if you want to increase the size, means you may increase. So visualization. So now it is like my previous one. So like that you may change the pattern also. So this one is called as a step value. So in the form of a step stairs and all it is coming now. So it is called as a step output. Then here you have a dot with a dot. This is mainly used for the dumbbell chart. Here along with the dot line will be there at the other end. So here I have compared a single one. Though if I created the same thing, that is two charts I need to create, then I need to merge both the things, means dumbbell chart will come. So these all are the things that are present in the Tableau software. So here I have I did so many things. So here these kind of charts and all also you can include. So this is your spike. Then based on the information you may choose. Here last one is called as dashboard creation. I'll explain you how to create the dashboard. Here dashboard option is there. If you click new dashboard, means new dashboard will come. Here at the left side, if you want to include, if you want to monitor 3 parameters alone, means that three parameters you should create it in a separate sheet. For example, if you want to view, for this example, I'm going to tell, first, I want to visualize the furniture alone, or next I want to visualize the discount of that particular, that is the items, total item. Then for that item, for each item, what is the discount and what is the sale available present in that particular year. Like that, based on your wish, you may check. That is, for example, in the case of, in another example, iris. Iris is there means iris setosa, virginica will be there, no? So if you want to visualize it separately, that is like that also you may choose. Then if any patient information is there, means how many male patient is there, how many female patient is there, how many are having the age greater than 60 or less than 60, like that also we can categorize. So we need to place it separately. So afterwards, what you want to do means, you need to include all the, that is, you need to drag all the things here. So first sheet, I need to drag and drop it here. So it is nothing but the name of this chart is called as a pie chart. So the next chart, I'm going to drag it here. So here it is in the form of a table. Here it is highlighted as a light color, dark color. The meaning is that it is called as the category of interest. Category of interest means here the dark color indicates it is having a highest value, highest category of interest. So this yellow color indicates a negative value. Then higher than that one, that is, it is given as 0 to 1000 means it is given as a gray color. Here you see, then more than that, more than to 10,000 range, to 1000, that is 2000 to 10,000, like that range is there means blue color, like that it is categorized in no. So for this simple information, we can categorize it easier. But if you are going for large, huge data set means categorization is very critical. So just by uploading the content in the Tableau itself, if we are just clicking the category of interest chart means it will convert all the information like this. Okay. The next one is called as, the last chart is called as a spike chart. So if I want to do any changes, say, if I want to view this, keep this alone only means it will hold the south region alone. So for that south, what is the information? That is, if I click this one means that information here, its sales will be 391 and its profit is like that, it will give the information. So for example, if I click the central alone means, keep central alone means it will keep the central part alone. Here you see, then its sales and its profit. Like that you can visualize it very easily. Okay. So also if you are connecting it in the online platform means, here I haven't connected in the online platform. So through the server and all we can connect. So if we are connecting like that means you can visualize the information correctly. So for example, if it is a temperature, if it is a pressure, or if it is a humidity means those information will get visualized here, or in the form of a chart also we can visualize. So the next another thing is that here, this is what your spike chart. So for this spike chart, if you want to change it into a bar chart means, here on the right side you have show me option. If you click, just click that one means here you have, it will enable so many things are enabled. So it is supporting only for those chart alone. So if I click that one means a bar chart will come. So this one is called as a stacked bar. Stacked bar, one by one, overlapping over the one, another thing will come. So this is called as a categorized one. So like that, based upon the application, you may visualize. For this kind of information, these kind of, so here you see spike chart, area chart, this is your area chart. This here previously I have given us bar spark line. So you may change it also, bar chart, then stack chart, like that you can visualize. The next thing is that, for example, again, you may go for this one. So here you see, it is a highlighted one. So I said, no, the highlighting categories of interest. Based upon the value, it will categorize whether it belongs to a 1001 or a 1201, like that you can change it. The next I am going to explain how to, first I am going to drag a category in the column portion and discount or sales in the row portion. Okay, for this one I am getting like this. If I want to view the sum of the sale present in that year means just I am going for average or some like that. Like that within the here automatically it will be changed to average. If you want to view the median or mode of that one means you may click median. So here you see the left hand side in the y-axis also it will get changed. So it is considered as the best one. So within the same scale, for example, this is a sale that is it will shows only the median. If you want to view the sum also at the parallel means you can give like this. So it shows the sum. Then if you want to view parallel both what median as well as the minimum of that one means it will give like this. So you may change like that parallel you can see it. So sum means one more sum is needed means again you need to drag the sum and drop it here. So like that it goes on. So one more row will come. So here you have a standard view. Entire view means entire view will come like this. So full window will get occupied. Standard view means normally what we are seeing, the normal things and all you can visualize. So this is the detailed calculation. One second. Here we have an addressing and partitioning. In the previous thing, we saw the pie chart. That is the pie chart with the south, east, west, and north. Like that, we have partitioned. But the table and all, what we saw is in the previous sheet and all, what we saw is just to contain all the information. That is, here you see, all the information will get clubbed together. So, for instance, in the year of 2000, like that. So, by using the addressing and partitioning technique, it will converted. That is, if it is a office means office alone, like that also we can categorize. So those kind of facilities are available with the Tableau software. So this one is so 1 second. Yeah, now we saw so many charts, no? Bar chart, line chart, pie chart, heat maps, scatter plots, and graphical maps. So now, right now we saw about the Tableau. So this is a platform. Here this is a license. Here you need to give. I have read like that. You need to give. Here you have seen so many things. No, here you have a Microsoft Excel option. Here you can upload the Excel sheet also in that form of text, PDF file, whatever may be. You can upload. Then that information will be displayed. Here like this page will come. You may upload any sort of information. That information will come at the left side. By using those options, you can link. So here automatically the things will come here. You may visualize the output like this. We saw just now, we saw that bar chart. Then next one is bullet chart. In this bullet chart, you can visualize what are the things present within that. That is here you see. It is in the form of a bullet chart. It contains all the information. Till this, what are the things present in that? That is, what are the things present in that particular country? All the information will get included here. Then here, this one I explained, that is based upon the coloring technique and all, it will categorize. So here, light color, based upon the color variation, we came to know which and all having a low value and which and all having a high value. Like that here, this bold, this dark blue indicates that is having a highest value. That is the highest sale when compared to that of the other one. So by seeing it, so we can say, no, So other than we need to check here first in the form of 200 after 22,000. Then we saw that 1,05,000. So if you want to see, that is by seeing itself, it is very, very difficult. So by using this table or technique and all, we can finalize which one is having a highest value. That is the thing is that in the case of 2024, the first will shift more. So it is a major one. The next one is date paths. Date paths means date weight also we can visualize. The previous case and all, what we saw means a furniture in the case of 2014, what is the same? 2015 and what is the same? Academic year wise also we saw. But here what is the thing means in 2014, month wise also we can visualize. Month wise here we can see that it is Q1, Q2, Q3. So the thing is that in the quarterly Q1, Q2, Q3, Q4. It is categorized, it is divided into four parts. 1 year, that is 12 divided by 4 means 3 months will be grouped as quarterly 1, quarterly 2, 3 and 4. Like that it is grouped. So in the quarterly, first quarter only, at that is January month, this much of sale happened. In the first quarterly, that is February 1 or the sale happened. Like that we can see. These are the detailed explanation. So this is given by the date parts. So the next whole stacked I explained you, that is a bar chart only. So within the bar chart itself, it will give so many things. For example, if it is 2016 means at the month of January, June, like that also it will be given. Based upon the information we have chosen, it will come. So here they have given region wise. Region wise means here we have a Canon, Lebanon. Here these are all the things, items. Region in the sense east, west, north, south. In that particular region, so in this particular year, how much sales happened. So this kind of, so this blue indicates Sony, Samsung items. This much of sale happened for this particular product. So the next one is tree map. Tree map in the sense, for example, if any in the year, in one particular year, furniture is there means it may be stool, table, chair, like that. So some things will be there. So sale is there. Sale may be a phone item or any stationery items or any Samsung or a phone, mobile watches, like that items will get categorized. Then in telephone, not telephone, in the case of TV means, so what is the company? So in that company, how many count will be there? Like that tree, sub trees will be there. So that kind of information will be here. So another example is that if a person is suffering from any disease means, first I want to categorize that whether that person has undergone any disease. That is disease or non-disease. If it is a disease means whether it is a grade 1 or grade 2, grade 3 or grade 4. Like that we are creating certain things. No? Like that for those kind of operation we shall go for tree maps. The next one is the area chart. Here how much information will be gathered within that particular. So within this, how many things will be there? Here category will be there. So in normally, so for each thing in the normal bar chart and pie chart and all, category wise we can visualize. But here you have the we have the option that within the same chart itself we can visualize so many things. Here you have a camera, laptop and mobile phone. In other cases in normal chart and all we should see the camera alone. But here we have these kind of facilities. So area chart. So if it is a camera means what kind of company it is, like that we can see. So here this corresponds to laptop of Dell. Then access will be there, Samsung. So many things will be there. Like those kind of information will be displayed here. Also, I explained, so if you want to view the values, exact value is needed means you may enable the label option. The next one is circle chart. For the circle chart, you should use the mark menu. The next, create and editing option. Create and editing table calculation. So create and editing table calculation means here, first you should categorize what is the furniture and all. Then here you have the option. There you need to choose what are the things you need to categorize. Like that you should write the code here and visualize it. Then addressing and partitioning. Addressing and partitioning means if you want to view the table means it will come like this. In 2014, what are the things present in various regions like that visualize. I said no, what are the things present in that particular region separately we want to visualize means you may go for this one. Here first it will categorize as central region. In that central region, what are the states that then consumer in the 2014, like that you can visualize it separately also. That is month wise, year wise, date wise, region wise, product wise, whatever you need to categorize like that. So patient wise, for example, if you are going for any patient information means you may go like that. So this is a clustering technique. The case of clustering technique means here you may group like this. So here in the left side you have the cluster. So you may club two sheets. In the case of dashboard, we can visualize the things separately. In the case of cluster means we can club two things. That is clustering. Here the next one is dashboard. I explained to you. So 3 or more sheets can be clubbed together. If you click any one of the chart means that entire thing, that is the things that is present in the central region alone will get displayed. If you click the east alone means that east alone information will get displayed. This is about your dashboard. The next one is the slope chart. For this to get based on your application, you may choose. Here for the slope chart, you may use this option to change. I explained, so this is your bump chart. Bump chart means you need to create the same chart for 2 times. I said no, 2 charts you may. For that 2 information repeatedly you need means 2 information should be dragged 2 times. So 2 column information will come. After that you may go for here in this itself you have a merge option. That merge option means just it will get clubbed together. The next step lines, for this one also you may go for this line option. Then here why we are going for this data visualization tool and all means here in the case of paper preparation also it will be more supportive. Whatever may be, instead of if you are if you are not interested in doing any cloud-based work means this kind of charts and all will be supportive for your result part. The papers and all usually we used to do either in the form of a normal table or in the form of a bar chart, or most in few cases only we are going for line chart and all. So different charts and all we may use it with the support of this one also. So just we are working with the data set only to generate the output. So after that, the same data set you may upload it here and generate the chart and paste it in your result part. So it will be well and good. You may change your fashion of colors also. So it will be considered as a unique one. So this, if you want to view the output in the parallel, in the horizontal also, you may change. So anyhow, anybody have doubt in this? So this is about your Tableau. Any doubts? Am I audible? Or you are following?
Yes, ma'am. Yes, ma'am. We are following it, ma'am.
Okay. Shall we move to the next one?
Yes, ma'am. Yes.
Yes, next concept is called as the Power BI. So the next one is the Power BI. So same as the Tableau only, it is also there. Here it is having the facility that when compared to the Power BI, it is more user friendly. But also here itself we can generate the data set by our board. There we have the option of uploading. Here also we have the option of uploading. Here in this Power BI Power BI software itself, we can create the data set. Also, the calculation will be made in that data sheet itself. That kind of options are available. Here also you can visualize the output in the form of a dashboard. In the dashboard itself, we can see 4 or 5 different charts. So it will be more user friendly. Also, you have the Wi-Fi option here. Share option is available. Using that, we can upload the information. So due to the shortage of time, I'm going to switch to the next one. now we saw separately how we are integrating that Arduino with our cloud. Through the cloud, how we are transmitting the information. Then separately we saw how we can visualize the output. Either either we can visualize in the form of data visualization tools. Separately also we can visualize without any cloud information also we can visualize the output. Here data integration, how we are integrating the cloud as well as the data visualization. So direct connection to the cloud data warehouses. Yes or no? So here we are by using the token or our Wi-Fi information, by sharing the information among the two, we can share the information in real time. So with the support of sensor, the gathered information will be given to the other end. So that information will be given to the output environment in the form of a dashboard. So use cases, it is mainly supportive for health monitoring or patient health. It is a patient monitoring only. Then in the crop management system also, it will be very supportive. Mainly it is more, nowadays it is most of the operation, that is IoT works and all, that is happening in the agriculture only. Also, it is worked in the patient monitoring, then it is inbuilt, that is incorporated in the ambulance and all. So healthcare and all, it is very, very supportive. So either in the remote area or in the ambulance or in the home itself, the monitoring will be done. Then business performance dashboard, performance in the sense whether the stock market is improving or decreasing day by day, we can visualize. Then what about the gold rate, stock market and all like that we can visualize. Then student performance analysis in the education, analytics in education. So these all are the various applications. Then benefits and all, faster insights, real-time monitoring, better decision making, improved collaboration. Improved collaboration means by sitting here itself, we can share the information to the other end user. So it will be more supportive when it is considered as a more efficient one. But still, it is having some challenges also. Data security and privacy challenge will be there. This will be happening in all the areas. If you are performing any new, if you are creating any new environment, means this will be a challenging one. Here also some challenge. It is considered as a challenging. Cryptography technique and all should be happening, should be improved. Then latency in real-time applications, that a delay may happen due to the wireless connection. Then data quality issues will be there. So if the information is not reaching the other end in a proper manner, means some delay will happen. Then integration complexity will be high. So installation, initially it will be very tedious only. Afterwards only it will be running in a smooth fashion. Then comes to the conclusion, then cloud integration combined with the IoT, the data visualization tools, it will transfer the raw information, it may be a text or any numerical information into the real world environment through the cloud platform. So it is best suitable for any real-time monitoring and that is mainly for patient observation or any traffic system, and also it will be supportive, then decision making. Then use of this data visualization tools, visibility by presenting complex data in a graphical format. As previously we saw a data set that is handling the central region and all, means so many informations are available. If you are using the chart and all, means it will be conformed or confined into a simple one. Here we see, here in the area chart, here itself, at each particular region, we can visualize what are the products they are getting. So we can club in a single one. Those kind of information will be more supportive for the end user. So performance will be improved and also efficient one. Still, this data visualization play a major role in all the fields, either in the form of a research or in a real-time application, it will be more supportive. Then queries.
Participants, if you have any queries, you can raise it now.
You can text your queries through the chat box.
There is a query in the chat box. Can we write paper on Blink plus IoT?
Sir, IoT means are you using Arduino and all to gather the information?
They are asking about some reference books, materials for study.
Sure, sir. I will include all those things in the PPT and also to upload in the to upload to your mail, sir. Then here, if so many platforms are there, I have listed so many platforms. No, by using that we can upload all the information. The thing is that you should link the information properly. About the simulation software, in the sense, what is the meaning here? We are linking the information from one end to other end. Simulation software in the sense we should gather the information. We should get the output by you either using MATLAB or simulate or Python. Using the data set, we can perform the processing. We are getting some output. That output we can visualize in the form of a data visualization tool. That one we can link. Can you share one example of things board? The things board, so just it is not supportive, sir. Sir, for me, things board means I need to install that one, or in the online platform also we shall include. So we should use, we should type that in the Google, sir. There you type. You just use your login to enter into it. The first page itself, that token login and all available, sir. That just to copy the token in the Arduino board, Arduino programming. Automatically it will get linked. Which cloud is better? So from my point of view, ThinkSpeak and ThinkSboard is there. ThinkSboard is more user friendly, sir. All the things are available in the that is it is in a visible one only. We don't want to search anywhere. By seeing itself, we came to know that these are the things are present. If you want to go for user ID means we can visualize it easier only. So just to copy that content and paste it in the Arduino programming and all means it will easily copying the content from one end to other end, sir. ThinkSboard is an open source, yes, sir. It is a ThinkSboard is an open source only. ThinkSboard, Tableau, Power BI, these all are open source only for ThinkSboard, yeah.
Okay, ma'am. Thank you. Since there is no more questions, we shall wind up. Today, I hope all the participants have a very good understanding of real-time cloud integration. Ma'am has added color and depth to the cloud-based IoT platform. She has really broken down the concept in a beautiful way so that even beginners can understand the cloud integration with real-time visualization tools and some case studies. Thank you, ma'am. We extend our heartfelt thanks to Dr. Ramya ma'am for the excellent session and valuable knowledge shared. Thank you, ma'am.
Thank you, ma'am. I extend my hearty thanks to the management of Arunachala College of Engineering for Women, and also the congratulations to all the coordinators, and thank you all for kindly listening and watching and my session. Thank you all.
Thank
If you
you,
have
ma'am.
any queries, I have mentioned my mail ID in the PPT. Kindly pinch there. Thank you.
Okay, ma'am. Thank you. We request all the participants to fill the feedback and attendance form, which is shared in the chat box. Now let's move into our next session, session 12. It's a pleasure to introduce our resource person, Ms. Krishna Priya, ATR, Adit Mitra Industrial Technologies, who is associated and she has an industry experience in IoT-based automation systems and emerging security technologies. Her expertise lies in addressing security challenges in connected and automated environments, ensuring reliable and secure deployment of IoT solutions across industrial applications. In today's session, she will be sharing a talk on security in IoT-based automation systems, a highly relevant topic in the era of smart industries and Industry 4.0. We are confident that her practical insights and industry-oriented perspective will be highly beneficial to all the participants of this program. Let us extend a warm welcome to Ms. ATR Krishna Priya ma'am and invite her to begin the session. Ma'am, welcome you, ma'am.
Hello.
Ma'am.
Ma'am, is it audible?
Yes, ma'am. Yes, ma'am.
Thank you, ma'am. Thank you for inviting me.
Thank you.
Good evening, all. I'm Krishna Priya from Adit Mitra Industrial Technologies Private Limited. In this section, I am going to discuss about security in IoT-based automation systems.
Yes, ma'am. Visible.
Okay, ma'am. Before going into the topic, let's see what forms the basics of a communication system and the evolution of communication system over years. The basic thing in a communication system, data transfer. That is the transfer of data from one point to another, usually from the source to the destination. So what is the need for this communication system? Initially, man stayed as a group in a single place, and communication took place directly as a oral conversation. But with development of transportation system and as the need of man increased, man moved and settled at different places, creating demand for new ways of communication. Basically, there are two ways of communication. Before getting into that, I'll brief you about the evolution of communication system over years. The first main and well-known communication system to all of us is inland postal letters. That is the method of delivering the post directly from the source address to the destination address through a human being. It was the first well-known source of communication. But the main drawback here is the letters took days, weeks, and sometimes months to reach the destination. In worst case scenario, like natural calamities and war, it was even left undelivered. Another demerit was the letters were not always leak-proof. Example, there was always a possibility for the postman to open the letter and to read what is inside the letter and to stick it again. We might all have heard of stories where when some sends money for a person in previous generation to letters, sometimes it is undelivered or the money has been taken away in the process of transferring it to the destination address. These are all the main drawbacks of postal system. As technology evolved, man moved from basic physical communication to communication over wires. That is, the next major breakthrough in the communication system is telegram. The invention of communication system, it was based on the concept of Morse code. Morse code is nothing but each and every alphabet and letter and numbers are given codes. That is a code series of dots and dash for each alphabets uniquely. Thus, when a person from the source here the main thing is when the person from the source, he gives the input. That is, example, if I have to send a message like, hi, I am Krishna Priya. Then from the source node, I will just type using the telegraph machine, hi, H. I will type the number of dashes, that is the short thing or dash dots, and the long press, it resembles dashes. So when I want to send the message, I will press the machine accordingly, the keys accordingly. And the signals here, it is very important to note here, the signals are transferred as electric signals over electric wires. And at the receiving end, similarly, the people will receive the same input which you give at the input side on the receiving side. And here the receiver manually, he converts the dots and dashes, that is the Morse code, into the information, that is readable text form. Here the information was just a text. That is, they also receive the same output, hi, I am Krishna Priya, in the destination address. And initially the telegraph system covered only a short distance, but in 1866, with the transatlantic telegraph cable, the telegraph system was able to connect continents, and now it was able to communicate between countries and continents using telegraph system. Over the years, the next great invention was by Alexander Graham Bell. When I say the name, I know you all remember this invention, telephone. It was a very big leap forward in the evolution of communication technology, because this is the first time that man was able to hear his voice message, that man was able to transmit voice message over long distance, and it was a real-time conversation. The telephone conversation, it depends upon the cables for communication. And next came the till telephones. It is to be noted that till telephones, the way of communications are wired. That is, the information is sent over wire. The next came the thing, that is the discovery of radio by Marconi in 1895. It laid the foundation for wireless communication. What was till then dependent on actual physical cables as medium, now began to use the wireless radio waves as medium of communication. It altered the way of communication, and it made the information broadcast across the world possible. Thus, the world gradually shifted from wired communication to wireless communication successfully. Now, let's see a brief. Let me say what is the communication system basically. What does the communication system consist of? The communication system consists of the source node, a destination node, and a medium of travel. It is this medium of travel that decides what is the type of the communication. Now here we have to know a meaning of an important term, packets. Now in layman terms, we use the term that are transferred in communication system as information, news, etc. That is what we transfer as news or information. But in terms of networking, these data that are transferred over medium are called packets. The packets may contain any form of data such as text, video, audio, image, sketch, etc. Example, in this Gmeet, the data that is transferred as packets is my voice. It is sent from my laptop, that is the source node, to your device. It may be either mobile or the laptop, that is a destination node, over the wireless medium. I'm sure there is no cable connection through cables between my system and to your concerned devices. Now let me tell here you can see the block diagram for assembling the basic communication system. The information source, that is here, I am the information source. I am giving the input data. It is transmitted through the antenna in my mobile. That is, every electronic device, it has antenna that that processes the data, and then it is transferred through the channel. That is, the channel here is wireless medium, radio waves, and as it is transferred from one antenna to another, the inbuilt noise removal filter, it removes the noise associated with the data. Now, through the channel, it reaches the destination, and at the destination, the information is in the destination, that is in your mobile or laptop, the antenna will convert it into the form that is heard by you. So this is the basic block diagram of a communication system. Now, let's see the type of communications in detail. As I said, the communication system so far is based on the medium of communication, that is wired and wireless. In wireless communication system, the packets are sent through wire, such as cables, coaxial cables, copper cables, and optic fibers. When I say cable, I think you all can recall the time when we used cable connections for watching TV. That is, before DTH, there were cable connections. But the packets when traveled, that are traveled to transfer through this wire are called as signals. These signals has both time and amplitude, and these are called as analog signals. Be clear, when the packets are transferred through the wires, they are analog signals. Now, what is the basic disadvantage of a wired communication system? We all know that the wires are laid underground. So, in one or other way, either the broadband person or the drainage person or any other person, even the individual persons may dig the ground for any purpose. It may cut the wires, and in that case, there will be a communication cut for few days. Similarly, there is a chance of eavesdropping or tampering the wires that leads to data leakage in wired communication system. Next, let us move to the wireless communication system. Here in this block diagram, you can see all the devices are connected through wires. As I said, the main disadvantage of wired communication system is its lack of mobility. Now, at present, the world is more mobile. That is, we are connecting each and every devices to each other, and we are moving every second. Each and every second, person is moving. So, but in case of wired communication system, it cannot be moved beyond a certain distance. And also, the cost of laying the wires underground is very high when it needed to cover long distance. Same is the case for installation charge. The next one is the wireless communication system. The analogs in wireless communication system, the input, that is the analog signal we receive, is converted into binary forms, that is zeros and ones. So what is basically a wireless communication system? As the name implies, it does not have wire. It takes place between two or more persons without the use of any electric conductor. It is through wireless medium. The most commonly used wireless medium is radio waves. The data transfer occurring in a wireless medium is usually in the form of binary. That is, the packets are in binary form. But we all know that the input is obtained as an analog signal, and the inputs and the data packets they travel between multiple antennas before reaching the destination. Here, this block diagram shows how the input analog signal is converted into digital signal. Here, ADC means analog to digital converter. It is this analog to digital converter that converts the input analog signal into digital signal. The ADC is present in almost all the devices to carry out this conversion. So, what is the best method? What is the most used ADC converter? it is the successive approximation ADC converter that is used in most cases, as it has as it can create high resolution binary output. It is the output of a system makes it more efficient. So we have to select the best converter for our communication. Now this binary signal is given to the wireless communication system. Let me shortly discuss what happens in an antenna after it receives the data packets. Till now, I have given the input, and the input I give in the form of analog signal is converted into digital signal by the ADC converter, and it is now at the stage where it in the beginning of the wireless communication system. Now you can see a circuit diagram. This is nothing but what is going on inside an antenna. By antenna, you can mean it as a mobile tower, because whenever we speak through phone, it passes through multiple antennas. Let's suppose I am in Chennai and you are in Kanyakumari. Then it has to pass through n number of antennas in between before reaching you at the packets has to pass through n number of antennas before reaching you at Kanyakumari. It is to be noted that every antenna has a ADC converter that converts the analog signal to digital form. In the main component of an antenna is the optocoupler. The optocoupler, it has two parts, the photodiode and the transistor. Here you can see the first part, that is a green plus and minus signals. It resembles the binary input, that is a current voltage, PV voltage. But the LED, that is the photodiode, cannot respond to a voltage. It will respond only to a current. So we are passing the voltage to a resistor. We all know that V is equal to IR. Using that concept, we are passing the current to the resistor and it makes the diode in the antenna glows. Now the RF resembles the glow of light. Then this when you go through a mobile antenna, you can see that the light at the top of the antenna is continuously blinking. It is not that the light is continuously glowing. It is because of the hundreds and thousands of signals it is passing every second. It seems like the light is continuously glowing. But it is what is actually occurring is the diode responses to every signal it receives. Since it receives millions of signals, it appears like that the diode is continuously glowing. Next, the transistor in the next antenna, it receives the light and it is converted. It converts the binary signal by passing through the resistor. The output binary form is read by the digital voltmeter at the destination. In every antenna, the ADC has to be an efficient one, because it reduces the in every transmission, the less the packet loss, the more efficient the transmission is. So the so we should include more efficient routing protocols to minimize the packet loss. Let's next move on to the wireless communication system. The wireless communication system types include the things like satellite communication, infrared communication, broadcast radio, microwave communication, Bluetooth technology, mobile communication systems, and Wi-Fi. Here I discuss about the things that are basic for the foundation of IoT. The first major type of wireless communication system is Bluetooth. We all use Bluetooth in our day-to-day life, but the major disadvantage of Bluetooth is it is a very short range communication with up to only 10 meters of distance. It cannot be used for this distance more than 10 meters. Next to come the GSM. The GSM is nothing but the basic mobile communication without Wi-Fi. Before some 10 to 12 years, all we were using was 2G network mobiles. You can consider that 2G network mobile as a real example of GSM. It does not have any Wi-Fi, but only the basic mobile communication. In GSM, the packets are transferred through multiple base stations, and after crossing the multiple base stations, reaches the destination address. Next, let's see Wi-Fi. Wi-Fi is the wireless fidelity, and it forms the basic of the what we are going to address in this session, that is IoT. The Wi-Fi technology, it uses radio waves for high-speed internet, and it connects multiple devices without the need for any physical cables. It makes the IoT system possible. Here you can see where all the Wi-Fi can be used. Wi-Fi can be used in office, schools, homes, and in every possible places where wireless communication is possible. Now let's next see what forms. Let's see a few details about wireless sensor networks. Now, what forms the basics of a wireless sensor network? The wireless sensor networks are nothing but wireless communication system containing a large number of sensor nodes. Each and every antenna it passes through. Now we call this as nodes. So the wireless sensor, each and every antenna in the network, wireless communication network, are called as nodes. And what are the functions of these nodes? These nodes functions as sensing, processing, and transmission of data. Example, just as a layman example, when the teacher during a school days, the teacher wants to give an answer sheet to a student who is sitting in the last bench, he will give first to the one now the teacher is the source. He will give first to it to the one present in the first bench. That student may be considered as the node. The next node, likely it will be transferred from student to student, that is node to node, until it reaches the destination student, that is the destination node. So these nodes, that is these students who process this data, that is who transfers this data, are called as sensor nodes. These sensor nodes, they collect the data and it forwards it through the wireless communication system to the base station. Thus, the network of such wireless sensors are called as wireless sensor networks. Now, the main advantage of this wireless sensor network is it eliminates the failure. That is, since it involves multiple nodes and it is based on routing protocols, it eliminates the failed node, that is the node which is not working, and it surpasses the failed node and goes to the next node which is successful. In this way, we can make the system robust. Next, these are some reasons why we go for wireless sensor network, because it helps in the real-time monitoring of the environment, because it forms the basis of IoT system. It can be used to connect multiple devices. In the last point, you can see this: the wireless sensor networks forms the basic essential component of the Internet of Things. Without network, Internet is not possible. That is, Internet of Things cannot be made successfully implemented. Again, the merits of wireless sensor network includes no cable connection. That is, it can be it can be used even in hazardous situations and situations which are very remote. It consumes very less time and less amount when compared to the wired system. Now, as I said earlier, the advanced routing protocols, when used in the wireless sensor network, it can deliver a efficient data packets. It can make the data packet delivery efficient. Now, let's move on to what is Internet of Things? We all think that Internet of Things is a very new concept. As it is under discussion in current days regularly. But what I say that Internet of Things is not a new concept, and it was there even in early 1980s. The first use of the concept of Internet of Things was in an university in USA. There, the local programmers, they connected to the Coca-Cola vending machine to check if there is Coca-Cola available in the machine, and in case of availability, if it is cold for consumption. This was the first instance of using IoT. In this case, they used this system to avoid unwanted travel from their working place to the Coca-Cola vending machine, thus making their it reduced their wastage of time, and it increased their working time. It was used to make things easy. And in 2011, there was an app called Ring, which was developed to see who is at the doorbell, and without directly going and opening the door, I can view it from in my mobile screen or in the screen in the TV, and I can speak to the person at the doorbell without opening the door. This was the major invention, app developed in using IoT in early 2011. Thus, IoT, it eliminated the need for direct human intervention. So, why do we need IoT nowadays? In present, human beings are even present in the border areas and in multiple areas where even life is very unfair. And people, that example, I am in Chennai, but my sister, she may be in some other foreign country, my brother may be in some other foreign country. But when I want to speak to them, it makes the connectivity irrespective of the distance, and it makes the mobility easier. So IoT is a game changer in today's world. Okay. IoT. So technically, what is IoT? IoT is a combination of both hardware and software. Here hardware means sensor and devices, and software means the Wi-Fi and the user interface apps to which we see the outputs of the IoT monitoring and control system. As the name implies, Internet of Things. It includes three things: Internet of refers to connectivity, and things refers to the devices. The main component of IoT are sensors. There are multiple sensors performing multiple functions in an IoT system. Example, the sensor gathers the information from the environment in case of air quality management, and in case of smart street lighting, and there is also in case of smart health monitoring. A doctor can monitor a person who is at the home without even visiting him directly. There are four types of IoT systems, namely the consumer IoT, that is, we are the consumers. We are using smart gadgets like a smartwatch and CCTV camera displays connected to our mobiles. These are come under the consumer IoT. The next one is commercial IoT. When IoT is expanded to a step further, that is, its application is to a greater usage, it comes under commercial IoT. Example, healthcare. In use of IoT in healthcare system to monitor patients, to track down their history, and everything comes under commercial IoT. It also helps in inventory management and stock management in case of big industries. Next come industrial IoT. The industrial IoT is the application of the The next is industrial application. That is applying in the IoT concepts to industries and making use of it to for energy management and maintenance of work in industries, big industries. And next comes the infrastructure IoT. That is infrastructure IoT. What we see as a smart lighting in the roads, smart traffic signals, air quality being displayed in boats in our capital city Delhi. They are all come under infrastructure IoT. Now, as I told earlier, these are the main components of IoT. That is sensors. The sensors perform the operation of data collection. Example, pressure. Example, humidity, temperature, light, motion, whatever the kind of the data, the sensor, there are respective sensors to collect the data. The collected data are then transmitted wirelessly, that is over the internet, Wi-Fi, Bluetooth, or any other form of wireless connectivity for data processing. The cloud here, that is the data is sent to the for processing. It analyzes the data, and this analyzed data, that is the output, is then sent to the end user through the user interface. Example, it may be a website, or it may be application, it may be the screen in your smartwatch, anything. This is the user interface through which we we see and monitor the output. These are the important applications of industrial Internet of Technologies, industrial IoT, apps, quality management, safety, automation, monitoring tools, and sensors. Industry 4.4. Now you can see the entire world is making use of IoT applications for making the life much smarter and smarter. It's moving towards further advancement each and every day. In this case, Internet of Things plays a major role in transforming the communication system across the world. These are the applications of IoT. As I told earlier, it includes health monitoring, homes, that is in automation system, home-based automation system, in banks and the retail environments, in offices. Example, if I want to see monitor the work staffs working in my office, I need not to go to the office personally. I should just open the app in my mobile and I can see through cameras. How are they working? This way it can be used in offices. The other applications include in production environment and in vehicles and smart city applications. Now, let us move on to the basics of this. The main point of this seminar: automation system. So, what is automation system? We have from the beginning we have seen what is communication, what are the parts of communication, the types, the main the IoT, the wireless sensor networks. All these are interrelated to each other because one forms the basis of other. Similarly, the automation system, it is one of the applications of IoT. As the name itself suggests, automation means reducing human intervention. That is, it behaves automatically. Example, let me tell you about the washing machine. If you are not standing throughout the one hour near your washing machine for taking your clothes, for rinsing it, for soaking it, it is done by the machine automatically. It reduces the human work there. Similarly, the automation system, it is one of the important applications of IoT. It makes use of the existing technology. The human brain itself, human advancement itself is in such a way that he keeps inventing new things day by day, and he keeps using it in day by day activities to make his work easier. That is what we can see in the evolution of artificial intelligence system and how it is transforming the lives of millions of people working in IT industry and in people working in every sector, and how it has transformed over the years. Similarly, the automation system also It uses the existing technology, that is the IoT, all the inputs we get from IoT, from the hardware, from the software, and it uses the robotics and artificial intelligence system, and this every possible inputs from the trending systems, and to help us to perform the tasks and process it with minimal human intervention. All we can do is we can sit in our couch safely, and we can see our mobile for monitoring what is happening in a distance thousands of kilometers apart. This is made possible using Internet of Things and automation system. The main aim of automation system is to improve the efficiency, the consistency, and productivity in areas that requires more automation, like manufacturing, IT industry, logistics, etc. In simple terms, through automation system, we are going to use more and more technology to control and monitor huge systems. Again, as you can see, the components of automation system, since I told before, automation system and application of IoT. So as you can see in the components, it has sensors, controllers, and actuators. The sensors, already we have seen in the IoT, it senses the data and it takes the input from the environment. It is then given to the controllers for processing the data. The data processing, it takes place in the controllers. The controllers, in case of automatic monitoring system, instead of going and switching on the motor switch, I will develop an app and make the connections to the sensors in such a way that whenever there is whenever the water in the tank is reducing to a low level, it will directly switch on the motor. That is, I need not to go and switch on the switch. The circuit and the design and the software, the sensors collect the data and switch on the motor switch immediately. It is this what is performed by the actuators. It performs the physical motions. Now, automation system, the key applications of automobile system, it includes in manufacturing, that is, wherever there is a risk for human intervention, wherever it can make the work for a human easier, it has its application in automation system. Example, it can be used in industrial manufacturing, logistics, and IT industries, and in homes, in energy management. That whenever in the morning when the sun rises after the 6:30 a.m. and 7 a.m., it will become brighter. So in that case, we can turn off or adjust the intensity of the lights in the house. These things can be done using automation system. Now, I think we are all clear about the basics of communication system. Its types, both wired and wireless communication system. The concept of wireless sensor network and how it forms the basics of IoT. We are also clear that how IoT is used in various parts of the world and various sectors, especially in automation system. Now, let me focus on the main theme of this lecture, that is the automation system, with an example of smart grid system. Smart grid is nothing but renewable energy system. The hybrid renewable energy system, it means the microgrid. What is the difference between smart grid and microgrid is, the microgrid also, it contains both wind and solar. But the thing is, it is not controlled or monitored through Internet of Things. The microgrid, that is a hybrid renewable system. Hybrid here means both the forms of renewable system. When controlled through Internet of Things connectivity, it becomes smart grid. Okay, then now there are many types of automation system, as I've discussed in previous slide. In hospitals, in industries, in house, many types of automation system are there. But in particular, in this lecture, I'm discussing about the smart grid system. The main reason for this is, in the smart grid system, it performs multiple multiple actions. It uses many number of sensors. It performs various activities like it reads the light values for solar, the wind speed, the SOC, the state of charge of the battery, the voltage we get from the as the output, whether the intensity of the solar light, the irradiance, solar irradiance, and the current, all these different parameters are studied and monitored and controlled in smart grid system. This is the main reason why I took smart grid as an application to explain to you the concept of automation system. Now, you can think that the world is slowly and gradually transforming from conventional power generation systems like thermal power plants to renewable energy system in the recent years. Nuclear energy, on the other side, though it is also a form of clean energy, it poses more risk, and there are possibilities of eye disorders. And we have seen in many countries they are just making the closing the nuclear power plants and moving to the solar and wind-based systems. The renewable energy system is gathering so much importance, and it's gathering attractions and investment in over from across the world. And India, as a country which is located across the equator, which is a sunshine country, the Tropic of Cancer, it passes through the in India, through India. So, as we are the tropical country, we receive a plenty of sunlight, and that is why the government has put so much importance in bringing out in tapping the abundance of the solar power generation in the country. We all know about the solar in the International Solar Alliance, which was initiated by our Prime Minister Modi some 10 years back. It gathers so much attractions, and so many countries which are having so much sunshine, they joined the Solar Alliance to make renewable energy system replace the conventional system. And also the government of India, they are giving us subsidy for setting up our solar farms in the rooftop of our houses and our industries and every possible places where we can set the solar system, solar panels. Similarly, there is also so much importance given to windmills and renewable energy renewable energy generation through wind farms. So this smart grid system, it is going to gain a huge popularity, and it is going to gather so much importance in near future that it is going to change the way that the power sector is working currently. The hybrid renewable energy system, it mainly consists of the solar. The name itself denotes it is hybrid. So it consists of the solar, that is the solar panels, photovoltaics, wind, that is windmill, and the battery units, that is to store the energy from the both the sources of sources of power. In case of solar, the input received is not always constant. Example, even on a sunny day, at one time of a day, there may be peaks hotness, that is the sun may shine very harsh on us. But during some time, it may be cloudy. These situations makes the input variable. We input a variable thing. Similarly, in the windmill system, the wind speed is not always constant. It always the wind speed is always not constant. One day the windmill may rotate, and the other day it will just stand still. So it is highly variable. The wind speed is highly variable. So in order to monitor these conditions, that is the wind speed, the solar irradiance, and everything, we make use of IoT into the microgrid system to monitor and control it in real time. These sensors in the IoT in the smart grid system, they generate a large volumes of data that must be quickly and accurately sent to the end user. Because what makes a system efficient, what makes a system reliable, it is the rate of transmission, that is the speed at which the data is transferred. Let's suppose I am speaking here at now, that is at 4:10 p.m. and you are receiving it at 5:15 p.m. Is it a good communication system? No, not at all. So the rate of the data transfer, the speed at which the data is transferred to the end user, and the accuracy at which the data is transferred, it shows the decides the effectiveness of a system. Also, the communication between the IoT nodes, that is similar to the sensor nodes I told in the wireless sensor networks. It has to be uninterrupted. In case of any failed nodes, or in case of any node that makes the communication longer, it should be able to surpass it and complete the given agenda clearly. So in order to make this, we have to rely on a good routing algorithm for network routing, that is for transmitting the data from one node to the another node. We have to use a good routing algorithm. The routing protocols, they play a crucial role in this IoT based grid system, because it transfers the data, sensor data, that is the data collected from the sensor, from one node to another node. There are several routing protocols and routing algorithms which are coming every year, and we should rely on a best routing algorithm which is very optimal for carrying out the communication. Okay. Now, now, as I told, the renewable energy system, it is gaining more importance, and many people invest in it. Let's say I invest in a windmill in Aralvaimoli, and some person from another state, let's say Andhra, they are also investing in the windmill, and some person who is sitting in America, they also invest in that windmill. Now they all wanted to monitor the activity of the windmill, that is whether it is running efficiently, whether the current that is generated is without any loss, and it is whether the battery is in state of charge. Everything has to be monitored. Is it possible for me to go there directly every day to check the state of the windmill? Practically speaking, it is highly impossible. Even for a person who resides in Nagarkoil or Aralvaimoli, there may be some practical difficulties and restrictions to go to the wind farm and windmill regularly. In that case, this smart grid system plays a crucial role to monitor the functioning and to control the functioning of this renewable energy source, that is the PV or the windmill, from long distance. It eliminates the need for on-site monitoring. And also in case of a doctor monitoring a patient through IoT, that is in a healthcare monitoring system, which is also an automation system, the connectivity has now improved, and he can send the data. Here the data cannot be sent over the GSM, as it is very, very slow internet connection. It is sent through the Wi-Fi and other fast communication system through the end user. But we also have to speak about a major issue in these types of communication system, which is called as packet loss. Whenever data is transferred from one node to another or from a source to destination node, there will be some packet loss. This packet loss, it has to be minimized in order to make the system efficient. And also, the longer the path through which the data travels, the longer is the risk of attackers, that is those who tamper the data and those who hack the data. It increases with the increasing route of communication. Since the renewable energy system is very highly profitable business, that is, it is also transforming into a very profitable business nowadays. There is a growing competition. And here it is to be noted that a windmill or solar panel, each and every windmill and each and every solar panel, they have unique operational ranges. And it is this operational range that decides the efficiency of a windmill. If this operational value, the range, is exposed to, if example, the operational range of my windmill, if it is hacked and exposed to a person of the competitor, he may easily use it to gain profit, which affects my company as well. So the data has to be highly secured to prevent it from attacker problem. Another crucial thing is the speed of data transfer, as I said earlier. Example, in case of deterioration of health or condition of a patient, or in case of a thief entering a house, the data has to be transferred immediately. The data has to be processed quickly to give quick response. The speed, the fast, and the transmission of the data is made possible only through a routing protocol that selects the shortest path for routing. Now, this shows the various steps involved in a smart grid system. The smart grid system has multiple sensors and smart meters, and it collects the data that is the current value and other data from the system. It is then transferred to the data transmission made through the wireless communication. As I told, the routing protocols and the routing algorithms are used from artificial intelligence sources, and it makes the routing faster. In case of any failure of nodes, this AI, it helps in making it helps in preventing the smart grid system from any lapses. These consumer interaction and the feedback loop is got through the mobile applications we have in our mobile application we have with us. Now this system, this image that shows about this shows about the difference between the conventional conventional grid and the smart grid. You can see the conventional grid, it is just a one-way communication. That is, the power flow from the power generating station. The power flows from the power generating station to the consumer. It is just a one-way communication. But in case of a smart monitoring system, that is smart grid system, the communication is two-way. It has two types of infrastructure, namely the power infrastructure and the communication infrastructure. Here, the power infrastructure, it transfers electricity from the generating station to the consumer. The next one is the communication infrastructure. The communication infrastructure, it sends the information from the consumer to the generating station. That is, through this, the consumer can send feedback about the power loss, the fluctuation in power, the fault in the smart meter monitoring, etc., to the concerned station based on which the smart grid monitoring is corrected and the system is enhanced. And also in conventional grid, we need on-site fault detection, which is not necessary in case of smart grid monitoring system. Here it is to be noted that the smart grids are nothing but the advancements of microgrids. That is, the microgrids with connectivity is called as the smart grids. Now, this is a general block diagram of a smart grid system. Here you can see this block diagram. It consists of both wind turbines and PV system. That is, it is a hybrid system, as I told, hybrid renewable system, and it is monitored over. It is connected over a network. That is Internet of Things. So, when a hybrid renewable system, it is connected over a network or connectivity, it is called as smart grid system. So this diagram, it resembles the general block diagram of a smart grid system. Here, the power generated through the solar panel and the windmill, they are sent to all the needed places. That is, example, to EV charging station. Here, ESS device here means energy storage devices, and the tier 1 to tier 3 loads. That is, schools, colleges, hospitals, to every possible places where they need, it is sent. And the residual power, which is the excess power, it is sent to the grid and stored, and it is given to the person whenever it is needed. The next thing is energy management in hybrid renewable energy systems. The microgrids, they fail to control and make quick adjustments to the wind speed and the solar irradiances, as they are continuously varying. Moreover, it is challenging to maintain the microgrid system in varying conditions, as it keeps on fluctuating the input to the system. Therefore, there is a need for monitoring the microgrid system, and so we go for smart grid system. Example, when a battery is full, that is, the state of charge is full, it should not be charged further, and it when we charge an already full battery, it may damage it. So the signal has to be sent to the grid to stop the current flow. This can be done only by means of using IoT. Similarly, fault detection is possible only when we go for smart grid based monitoring system. These are the main challenges in an energy management system in a HRES. As you can see, fault protection and fault management. We need on-site fault management in terms of microgrids, and communication and interoperability, lack of communication, because the not all the users and not all the persons involved in the communication system in the HRES are connected to each other. But in case of smart grids, they are interconnected through network. And the battery degradation and lifetime management. That is, once the SOC is reached, the battery should not be recharged. All these can be checked only when they are connected over a common internet, in common connection. So these are the challenges in the microgrid or the HRES system, which are addressed in the through the smart grid system. Here, the optimal storage utilization means whether the power generator is stored and utilized properly. Whether the economic dispatch here means let's say that when the power system, it is a solar or wind is generating a power of 10 megawatt, but the actual power that is received at the end is only 5 megawatt. Here, almost half of the power generated is lost or wasted on the way. But it affects the economic, affects the person who invests in a great way. It reduces his economic profit. So these and all can be monitored and adjusted only by means of smart grid system. Now this diagram, it shows us how the various sources are connected through the microgrid through an IoT. That is, it is the basic of the smart grid system. That's how IoT is used to monitor the microgrid system. Now, in a smart grid system, with IoT-based smart grid system, I told you earlier that there are so many sensors available. In this diagram, you can see the irradiation sensor, the ambient temperature sensor, the current and the voltage sensor, and these sensor input are sensed and they are sent to the microcontroller board. This microcontroller board, it processes the input received through the sensor, and it is then sent to the cloud, that is the Wi-Fi or any other form of network. Here the MySQL Web PSP means the software, it means the website or the web server through which the app, through which example, a web monitoring with ThinkSpeak platform is the app through which we monitor and control the input, this varying input and output of the smart grid system. Now, this is the general architecture of an IoT smart grid. First, as we already discussed, first is the perception layer. It has all the sensors and devices which collect the data from the environment. Next is the network layer. That is, it consists of the edge devices. Edge devices means means the mobile phones and other devices through which the we transfer the data. And then comes the cloud layer. The cloud layer, it performs the options of storage and analysis of IoT data. It is then given to the user interface, and interaction happens by monitoring and controlling based on the output received. Now, another major portion of this lecture, it focuses on the secure data communication in IoT. We all know how important is security in terms of communication. Let's just have normal physical communication. When I go from one place to another, I will select a path or a road which I feel very safe, which is theft free, which is free from in which the roads are clear and are not blocked. These are the options we analyze and prefer before communicating before going to any places. And we have in mind is whether the path we take is safe. So the system has been developed. IoT is there. Smart grid is developed using IoT, and many other applications and automation systems are developed using IoT. But it was the security, but whether the data is sent through it is secure. It is the very important thing and the crucial thing in a communication system. For example, before a few days, you all might have heard of the news where a CCTV footage leakage has happened in a hospital. And we saw a report where millions of passwords, they have been leaked online. And there has been advisories. That is why the password system, management system, whenever we create a password, it gives us a set of specifications. Use a capital letter, use one symbol, use a number, alpha. It should be a combination of both alpha numeric system. These are the inputs to make the password stronger. Now that every person is connected through internet, there is always a high chance of data theft, because my data may be just a data for me. That is, my date of birth may be just a data for me. My insurance number may be just a data for me. But for a person who makes use of it to earn money, for a person who makes use of our Aadhaar number to find in whichever bank we have our accounts, it is a very a great source of data to earn. So we should be very careful about the system, careful about whether the system is highly secure in order to make it free from cyber threats. Example, if just think if there is a data leakage in a smart grid system, it will affect the entire each and every area of the smart grid system, as everything is interconnected, and it processes a huge volume of data. It may affect the end user and every person who are benefiting from it. So secure data communication should be made possible in IoT devices. When I say of secure data communication, we know the thing that comes to my mind is cryptography, right? The basic CSE persons, they all know what is cryptography. So till this step, the electrical engineer, he has given us an output, that is which is to track in the to use in the smart grid system. Now it is the input for an CSE computer science engineer. It is now his duty to safely transfer this data from the source to the destination. Here, once the packet is received, a key is added, that is a cryptographic key. It is added based on the RSA algorithm. The key is generated and it is added to the data packets, making it a secure secret message. Remember, when the data packet crosses each and every node, the node, that is the node through which it passes, it is called as public channel. It is only the source and the destination node, they are called as private players in this public privately cryptographic system. Whenever the data packet is transferred from one node to another, a public key is added and removed in every node until it receives the destination node. At the destination, the private key that remains as a secret, it is decrypted at the by the end user, and the data is retrieved as in its original form. Here, in order to make this system secure, and in order to remove the redundancy in password, there is also a step called as revoke key. That and also the keys that are already generated, they are destroyed to make it from easily predictable, to make it less predictable. Just as how the postal letters contains the from address and to address, these communication, this wireless communication, they have the SIM number or the IP address as the source and the destination address, and the key, it is decrypted only at the designated IP address. Now, what I discussed is the traditional cryptographic method of key generation. But are we discussing it in context? We are discussing it in the context of smart grid system. Is smart grid system a traditional method or a dynamic one? The smart grid system is a dynamic one. It keeps on changing each and every, the inputs, the things they monitor, it keeps on changing every second. So the smart grid system is a dynamic system, and it needs a more sophisticated cryptographic algorithm. And here we discuss about the post-quantum cryptographic algorithm which uses ECC to secure the data transfer in this IoT-based smart gate automation system. The PQC stands for post-quantum cryptographic algorithm. The PQC are new cryptographic methods designed to resist attacks from the future quantum computers. Quantum computers means the computers that perform operations at a very, very, very fast pace than we really think. So the PQCs, they are designed in such a way that it resists the data attacks even in the future quantum system. The PQC, it relies on hard mathematical problems that are able to resist the quantum attacks. The main point here is the PQC, it is directly integrated into the digital hardware. That is, it may be in any device, that is a device which is a part of the smart grid system. In case of smart grid system, the devices such as smart meter, controller and SCADA network are integrated with PQC algorithm. The main purpose of PQC in smart grid system is to generate crypto agility. So what is crypto agility? Crypto agility is nothing but the ability of the smart grid system to quickly and easily switch, update or replace the cryptographic keys and protocols without disruption and disrupting the operation. Example, if the system detects that there is a chance of a threat, it replaces the cryptographic key immediately. This is called as crypto agility. It is this crypto agility that makes the PQC, that is the post-quantum communication cryptography, ahead of all models that are vulnerable than this PQC. The PQC, it has the main aspects of PQC are lattice-based cryptography. That is, it means it helps in supporting the faster key generation with moderate key sizes for devices such as smart meters, EV chargers, etc. It makes the frequent authentication and encryption possible. That is, I told no, in a crypto agility means crypto agility requires the keys to be frequently altered and replaced. This is done by the lattice-based cryptography. And next is the code-based cryptography. Here, the code-based cryptography, it generates the exceptionally fast encryption and decryption operations, which helps in dynamic response in case of the dynamic system like smart grid system. It is used in the backend application such as control centers, key management servers, etc. And it improves the robustness of the system. Robustness means the ability of the system to withstand failure. Now, let's see a real-time scenario where a person A, he sends the data to a person B. Here, the person A, that is Alice, is sending data to the person B, that is Bob, for person B over a public channel. When A sends a data to B, a public-private key is generated at B. Here the public key is used for encryption and the private key is kept as secret. That is, the private key is secreted only when the message, that is the data packet, reaches the person B. These are the steps that are taking place in the decryption process. That is, first the key generation, the public-private key pair is generated. Then the next step is data preparation. Here, If the data sent by A is longer than the bytes that can be processed by the PQC algorithm, it is splitted into small blocks and are processed individually. Thus, each block, that is each block, split block, they are encrypted separately, that is individually, with using a public key generated by B. Then the blocks are joined once the individual encryption is over. The next step is transmission. Now the encrypted file is sent over a secure channel. It is directly routed to B without decryption to ensure confidentiality, because if once decrypted, the message can be read by anyone. So it is sent encrypted key sent along with the encrypted key. Now it receives the destination B. On receiving the destination, the process of decryption takes place. The encrypted key received is now decrypted using the B's private key. The first step itself, we saw that a public and a private key is generated by B. The public key is assigned for encryption and the private key is held secret by B to perform the operation of decryption. So now when the B receives the data, he uses the private key for secure and decrypts the data for secure transmission. Thus the PQC, that is the post-quantum cryptography, transfers the file by breaking it into smaller blocks and reassembling it after destination. The PQC, the main advantage of PQC is it also minimizes the latency in the system, that is the lagging of the system. Here, this is the in this diagram, the top portion, that is it shows the architecture of a smart grid system, and the portion below it shows us the routing taking place in the smart grid system. Let me first just describe briefly about the architecture, that is the sensing energy sensing layer. The energy sensing layer, the main source, it has the sensors, that is it gets the information from the battery, the PV system and the grid. And the information from the sensors, they are given to the data, for the raw data is given to the processing layer, pre-processing layer. The processing layer, it processes the data and it extracts the needed features and it normalizes it, and it is then sent to the relay node layer and to the intelligent routing layer for transmission. Then it is then at the security layer, the process of encryption and decryption takes place, and the data in the transmission and visualization layer, the after the decrypted data is shown to the end user. The PQC cryptography also includes a concept called as ECC, that is elliptic curve cryptography. The PQC algorithm uses ECC model to improve the robustness of the system. Here, it includes the following steps. ECC parameters are selected and configured. The cryptographic environment is set and the ECC parameters selected earlier are initiated. The parameters for the that is to be given as the input for the algorithm is known as the ECC parameters. They are selected and they are initialized in the next step. And then the key public private key is generated. It involves the same steps as we see in the PQC model. That is creating the public private key pair. That is each IoT device. Each device linked in this system, it creates a public private pair, and the public key is sent to the other devices in the system, while the private key is kept as secret. Our next step is the data encryption. It is whenever the device in the smart grid produces the data, the packets are encrypted using the public key, as I explained earlier. The ECC, it changes the data to a form that is unable to interrupt without matching the private key. That is, without knowing the private key, we cannot process the data transmitted by the ECC. The primary objective is to ensure that the sensitive data remain inaccessible to the unauthorized parties. Next comes the transmission of encrypted data. The packets encrypted in previous steps are transferred from one device to other through the secure communication path. And then the after receiving the packets, the final stage is data decryption. The final here using the ECC private key that matches with the sender's public key, the encryption takes place. The decryption takes place. This decryption process restores the original message in a readable form and it is given to the user interface. Now let's see the advantages of ECC. The keys generated in the ECC model are very hard to crack. That is, even if the keys are encrypted, it prevents the hacker from extracting the original meaning as the ECC model uses message authentication codes and cryptographic hashing technology to confirm the data integrity before delivery. That is, each and every device is checked for its identification, and only when the identification in the MAC matches, the data are delivered to the concerned device. Now we have seen about how security is carried over in the smart grid system. We have to know that the encryption decryption process and the routing process, they take place parallelly in a communication system. That is, whenever a packet is transferred from the one node to another, in every node encryption takes place with the public key and decryption takes place with the private key. So the by routing we mean the transfer of nodes from transfer of data packets from one node to another node. Just like we are saying route to some person who asks for address, go take the right, then left. Similarly, routing is telling the route to select which nodes for transfer. Selecting an efficient routing algorithm is crucial for a data communication system to make it faster. The next advancement is the use of optimized routing algorithm that finds the shortest and successful route to reach the destination. So here, optimized routing means we already have n number of nodes. Optimized means, the term optimized itself means minimizing the work. That is finding the best out of the best of things is called as optimization. So the optimized routing algorithm, it finds the shortest and successful route to reach the destination node. The traditional algorithm, such as Dijkstra's algorithm, selects the node that is nearer to the source node, irrespective of its distance to the destination node. And also, in case of Dijkstra's algorithm, the node is compared only to one node compares itself only to two nodes that are nearer to it before routing. These advantages makes the Dijkstra's algorithms very traditional, and it is not suitable for a dynamic and changing system like smart grid system. Now, let me discuss one of the basic routing protocols called as the particle spam optimization protocol. Here, the PSO is a bio-inspired algorithm. That is, the bio-inspired algorithm means those algorithms which are created by noticing the activities of any organisms. Example, ant colony, chicken swarm optimization. There are some examples of usually used bio-inspired algorithms. This PSO, that is particle spam optimized routing, is based on the behavior of birds in reaching their destinations. The main reason for going for optimized routing algorithm is it dynamically adapts to the changes in the network and avoids the congested or energy drained nodes. Now let me discuss the PSO briefly. The PSO is a basic form in this bio-inspired algorithm, And here I take it to the case study to explain the routing protocol. Now, let me, whenever the packet is sent for transmission, it is sent from the source node to the destination node through multiple number of nodes in between. Let us consider we have 50 towers in the network over which the packet travel. For all the 50 towers in the PSO algorithm, the values of alpha, beta, and gamma parameters are set. That is, it is nothing but the possibility of directions. For a node to travel from one, for a data packet to travel from one node to another, it may either have take place in x direction, y direction, or z direction. So these are taken as alpha, beta, and gamma parameters. Now, the number of iterations are set. That is, it is up to us to select the number of iterations. It may be 5, 10, or 12, 25. Any number of iterations can be set. Let us say the iteration value is 25. Then, in order to travel from one node to another node, it checks for the PSO runs for 25 times before moving. But all these takes place in a nanosecond. Now, the algorithm also considers two values as P best and G best. The initial path of transmission is considered as P best, that is particle best. Here, the nodes are called as particles. And the actual best path, after carrying out multiple interactions, it will come to a conclusion, right? This is the best path through which we can transfer the node. It is called as G best. When P best is equal to G best, the iteration stops. But in this case, if I send a message from my mobile to my mobile, that is, I'm sending a message to myself, it is the case when G best and P best are equal. We know that 99% of time the G best and P best are not equal, and the iteration continues. The particle swarm optimization, it compares the first particle, the first node, with the 4 nodes which are nearer to it, but in the direction of the destination. This makes it different from the Dijkstra's algorithm. So when it compares itself with the nodes, it will select the node even if it is longer, if the node is free for communication, than going to the node which is shorter but is busy. In this way, it eliminates the time delay. Now, it selects the node for transferring the data. This node which it selects is called as anchor node. Now, the process continues. Each particle is compared to the next 4 particles and the anchor node is found. Sorry, 1 minute. And upon comparing, the anchor node is selected. Then from the anchor node, it again compares itself with the next 4 nodes. Likewise, the cycle continues. Till we find the destination. Here, the main drawback in PSO is when it discards the shortest path, that is the node in the shortest path, it will consume more time. And also, it is not much efficient as it is the basic PSO algorithm, basic optimization routing. The drawbacks are it needs a greater number of iterations and it is a time-consuming process. Now, I am running this. I am showing you how a smart grid is monitored. Here we are using the routing algorithm called as PSO, and it is the tool by uses NS2. The cryptographic technique is ECC, that is elliptic curve cryptography, and the packet of the size 415 bytes is transferred. The deployment area is the distance between one tower to another tower. That is, it means if geo last tower for every 500 meters, we can take it as 500 meter to 500 meters is the deployment area. The data rate is the speed at which the data packet transfer from one antenna to another. Now that I consider communication in I am giving all these inputs, and I am running the NS software to show you the output of a smart grid system. This is the screen showing the how routing protocol works in a node of 50. You can see the small circles with rounds. They are nothing but nodes. It starts from source, that is 0, and ends in 49, that is destination. In between there are multiple number of nodes, but we know that the PSO, you can see from the source node, the node 21 is closer than the node 14. If we have used the Dijkstra's algorithm, the Dijkstra's algorithm would have been blindfoldedly selected node 21. But in case of PSO, the node number 14 is selected. That is, the particle 14 is selected because it is closer to the destination than 21. Similarly, now the 14 became anchor node. Then from the anchor node, we can see check 4 nodes, 21, 17, 18, and 28. Here, node 18 is closer, but it selects node 28 because node 18 is busy at that time. Busy means it when it keeps on processing data from multiple phones and devices. At the time, the communication system will be busy. So it selects 28. Similarly, it travels through the particles that are darkened with black circle, and it reaches the destination node. This graph shows the packet drop study. That is how the packet drop is minimized with the using PSO in a smart grid system. This shows the energy consumption in a energy consumption. The energy consumption should be less in order to make the system more efficient. So we can see how the energy consumption has been dropped by using the PSO algorithm. This is the hardware setup, that is the prototype model of a smart grid system. Here you can see the controller, that is FPGA controller, the DC to DC converter, the battery, the inverter, the rectifier, and the display to see the result of the system. And this is the IoT web page that in the in the smart grid architecture, we have seen the last layer, right? That is visualization layer. It is the visualization layer where the outputs from the smart grid are monitored. The outputs here are PV voltage, PV current, DC link voltage, wind speed, that is from wind farm, grid voltage, grid current, and battery SOC. Battery SOC is state of charge, which means the percentage of charge in a battery currently. All this can be monitored from a distance without going directly. Now, these graphs, they shows the outcomes of the PSO based routing system. The first graph, it denotes the energy consumption. Energy consumption means how much energy is consumed for sending and receiving the data. The lesser the energy consumed, the better is the battery lifetime. So, in future, if there is a better routing algorithm which has lesser energy consumption, the system moves to that routing protocol. Similarly, throughput. Throughput means it is a successful rate of delivery of packet over a network. That is, how many packets are successfully transmitted. Higher the throughput value, higher the efficiency of the system. Now, network lifetime. Network lifetime is how long does the node survive? That is, how long the node performs before its battery is dried. How long the nodes work properly before the energy is completely depleted. It is studied using network lifetime. The next graph is end-to-end delay. The end-to-end delay, it denotes how much time the packet takes for delivering from source node to the destination node. The less value represents the faster communication. When the end-to-end delay is less, it means the communication is faster. Then comes the packet delivery ratio graph. The packet delivery ratio, it is the study of how many packets reach the destination successfully. Based on the, now we have seen the graph, we, we may send multiple packets over a network, but not every packet reaches the destination successfully. This is studied using the packet delivery ratio. Now we have seen multiple parameters like energy consumption, throughput, network lifetime, and end-to-end delay, and packet delivery ratio, which shows the efficiency of an algorithm. Here we saw for PSO-based routing algorithm. So what is the future of this automation, routing and the security system in IoT-based automation system? As I told earlier, as the world is dynamically, the world is gradually moving towards the AI-based system. The AI-based concept and algorithms, they can be actively involved in finding the in making the routing protocol which increases the efficiency of the system. Example, in case of basic algorithms like PSO, we can go for more advanced algorithms which makes the system more effective. And by incorporating the new and emerging ideas and techniques such as better optimization techniques and routing algorithms, and also the security protocols, a more effective and robust IoT-based automation system can be built that is useful for control and monitoring of the system from anywhere and everywhere. Thank you.
Participants, if you have any queries, you can raise it now. Since there is no queries, we shall conclude our session. I hope from today's session, all the participants would have enriched your knowledge with basic concepts of communication, IoT automation system. We were made to travel inside the security in IoT-based automation system and how IoT is performed in security-based automation system. And this session has automatically given a broad sense from the fundamentals. Thank you, ma'am. We extend
you,
our
ma'am.
heartfelt thanks to Krishna Priya ma'am for the excellent session on security in IoT-based automation systems, highlighting key challenges and solutions. Thank you, ma'am.
Thank you, ma'am.
We request all the participants to fill the feedback and attendance form which is shared in the chat box. Now let's move into our final session. Let me introduce our resource person, Engineer Imai sir from United States. He has extensive industry experience in embedded systems and advanced aerospace technologies. His work involves developing high reliability embedded solutions for mission critical applications, aligning with the latest technological advancements. In today's section, he will be delivering a talk on emerging technologies in embedded systems, offering valuable insights into current trends and future directions in the embedded domain. Let us extend a warm welcome to Imai sir to begin the session.
Well, thank you. Hello,
Thank you, sir.
everyone. Hope you can see the screen. Can someone confirm that you can see the screen while I'm sharing? Please. Can you guys hear me well?
Sir?
Ma'am, can you hear me well, ma'am?
Yes, sir. Yes.
And,
Yes, sir.
and also the
Yes,
presentation.
everything fine.
Thank you. I'll start from here. What we are going to discuss about today is the emerging technologies, the embedded systems. But this, at the same time, we'll deep dive into aerospace embedded system rather than going on a general embedded here. Okay? Because I'm from an aerospace background, so I tend to lean towards aerospace, and we'll go through it from here. So what I do is like I work as a software engineering person here, and my preliminary experiences on the aerospace. And I've been with the aerospace for embedded aerospace for 2 decades now. I work with most of the fuel systems, electrical brakes, ground refueling, and automatic flight control system, sort of learning gears and other stuff. These are the areas where I have primarily contributed to, and I work. And the educational background, what I have is I did my bachelor's in electronics and communication. And then my master's is from Stevens Institute of Technology. And I do have a couple of certification courses based on system improvement and application. So this is preliminarily me. And what I do currently, I work for a aerospace company, and I lead a team of engineers, predominantly embedded engineers plus test equipment engineers. And I work as a software engineering manager here in senior positions. What I do, like I said, I have 2 different teams that it seems to lead. One is embedded software, where we develop embedded products. And then another team is the test equipment, we call it our validation team. So where test software test machine is developed, which is in turn used to consume the this embedded software. So these are the 2 different teams, and which I work with, and this is pretty much me. We'll go through it one by one and see how things line up in the aerospace industry here. So this is a rough agenda what I have for this call today. We'll talk about the process in aerospace engineering, why aerospace engineering is different, and why the embedded system developed in aerospace engineering is taking a longer time, and the reasons and preliminary contributors for it. And then we'll talk about the software engineering process, the software engineering architecture-wise, what is happening in the aerospace industry. Then touch base a little bit on model-based system engineering. That's where the new trend is all about. And a few liners about neural networking and how neural network is implemented in aerospace. And then we'll talk about data analytics. Because data analytics is another hot topic in this time. So let's touch base a little bit on it. And then we'll walk through a little bit about how the embedded hardware is designed and what are the criteria for us to go through it and design it. With that, the last and not the most another important and latest trend in technology is cybersecurity. We'll touch base a little bit about the cybersecurity there, and then we'll go back and spend some time on the fuel system, and explain how the fuel system and what it does and stuff. And then we'll cross compare with the other industrial standards, like we'll compare with medical, aerospace, automobile, and the locomotive design. So we'll compare again with each of the standards and how it is different, and then I'll wind up with a high-level summary of where we are heading towards and what is the result, right? And then I'll try to give an ample amount of time for a QA. I love to have those QA sessions because the more you ask the questions, I can answer them better. Right. So this is how the structure is going to look like, and let's go. And if you have any questions or anytime you want to stop me, please let me know. I'll stop and answer your questions and go for it. So a little bit about the company whom I work for. I work for Siemens Precision Production Corporation. This is a company who's one of the global leader of manufacturing advanced sensing solutions for aerospace and defense. Because of the defensive nature, I may not be able to explain everything into the core, but we can talk about commercial airlines here. So this is a company, and I just wanted to share some fun facts with you guys to start off, right? This company is started in 1930s. However, the name Siemens Precision Products came in 1960. Then in 1983, this is being purchased by another company and renamed as Tripolis. Okay, there is another change in 1990. The company name changed to Convention. 2012, another company acquired, and the name changed again to United Technology Corporation. Then there is a merger with Collins Aerospace in 2018. And all this time, Siemens Precision has been named all very different names. Say that. And then in 2025, which is pretty recently, the company is being acquired by TransTime Group, and it is renamed back to where it started in 1960. So we are back to the same name what we had in the past. This is just wanted to share how the companies are changing around. And I personally been a part of Goodrich Corporation for a few years, and I worked with the United Technology Corporation for 5-6 years, and I'm a part of Collins Aerospace. And I've been always a embedded software engineer, and I led a team around it. So what are the products this company produces? Fuel systems. I'll stick to the commercial side of it. So I just wanted to, when I say any product here, it is in a commercial airline, which if you hit it up to Google, they can find all these systems. So fuel system is a system which is developed to calculate the fuels in the aircraft and move the fuels around from one tank to another, and how the engine is being fed at the end, and what it takes the engine to be kept filled and the flying through from the takeoff to the end point. The system calculates the fuel in the tank and also transfer fuels from one tank to another tank. I will step around it. The second system is a proximity sensing system, which let me put it this way. If there is a door and the door is being, how do you identify the door is closed or open? And how close the doors are, whether it has an ample space in between to be airtight, and all this, the scenarios are calculated by the proximity sensing system. And this system is deployed in cargo airplanes and also any commercial airplane you have blue. So they check the door closure, landing gear, and the cargo bay area and other stuff, whether it is closed and packed tight, all those sensing is being done using that. And the other one would be work on is the HUMS, which is called Health Utility and Management System. The core purpose of this is to monitor the airplane or helicopter's current tier and gears and report it so that the correction can be made at that time itself rather than going through a quality check every time an aircraft is landed. This will give you a highlight of where are the concerns and what are the deviations of the quality. And finally, this is another key product which we've been working on for a while is called electric brakes. So this works similar to any other brakes in the car or anything. So what is different about this brake is all this time the force is converted to a CAN message and it is deployed to a motor. And these brakes are used on in the commercial airlines right now. So the 77 or Airbus or Boeing use this. This brakes are mostly controlled with the control loop. So you guys know, we'll talk about the control loop. So the control loops, when the command is passed through, the control loop will the brake pedal. The force is applied to the brakes, and it will collect the feedback and adjust to the need of the current scenario, and then it will, the brake. It allows the brakes to stop the right amount of time. So this is a process what we follow in aerospace industry, which is called TO178C, and why I wanted to talk about it, right? So in the embedded world, the commercial like on an automobile industry, any other consumer product like a washing machine, fridge, or any other embedded technologies, what I've been a part of. What happens is we deliver the product fairly quickly. The prototyping I think will be rapid. Then we just deliver it. Right? But in aerospace, if the project is coming to a live, it is getting deployed, it takes 3 to 5 years. Sometimes it takes up to 8 to 9 years if you exclude the development and R&D phase of the program. And why this time frame is taking? What is so unique about this product? And why the time frame is taking a longer time? That's what we want to learn about why this process is different. Is like just to see what the importance of D170. And the D170 is a guideline which is being approved, or it's a standard or a guideline, you can say, approved by the European Aerospace Union and the Federal Aerospace Authority. So this is the collective standard across the world right now, just following for software development. I just wanted to give you guys a overview of how the aerospace systems work. What are the frameworks? So they are driven, heavily driven by the implementation and process. So if you see here, if at the top level, what I'm saying, what I have highlighted here is at the aircraft system level, there is the AR-34754 to the picture, and that uses the command line to follow to get their aircraft certified. And then if you the division below, you can see that aircraft level security. Let's not go deep dive into security and other stuff. So the 2.254, it's the hardware development guidelines, which we'll talk about a little bit because the embedded software comes along with this stuff. So any chip, any processor board, any PCB board layout, anything that's been developed, it has to follow the 2.34 process. And for software and development guidelines, we have 2.178P. And the other latest trend these days are the model-based development. So they use the guidelines to reach there too. And why this guideline? These guidelines are saying, helping us in a way that we understand the system, security, and what are the needs and what the rigorous of this process is what the standards explain. And it gives the checkpoints to go through each STEM and say whether we have achieved that by following this process. What are we getting? It's like we just try. This process is helping us to identify the safety of the program. Right? So the whole with all these numbers at the end, what they're trying to convey is what is the safety standard and how safe this product is, how much it can withstand the different temperatures, how much different pressures and any other vibrations, and how secure it is. Right? That's safety of the system is what this is all about. And flow down to the software side of it, because software is closely related to the embedded system here. So, like we just talked about this radio, so FDPs, the airborne systems and equipment distribution. This is the standard currently approved by FAA and ESA. FAA is the Federal Aviation for the United States, and then ESA is the European Union. Being that said, there are two big commercial airplane products right now available in market, which include already covered, one is Boeing and all that. These are the two big hitters in the market. And we do have Bombardier, Pilatus, and other commercial airlines, which is jets, but the bigger airlines come from Airbus and Boeing. So, and the software standards, how they differ from each type, right? So you don't have every software the same level. Some softwares, if there is a failure detected in the software, it's not going to lead anywhere. For an example, if I have a ground station, if there is a problem with that, there is nothing going to impact the safety of the person. So the safety standards are defined based on what are the impacts of the life, right? It's like how it impacts in the life. Like the loss of life is the key factor here. So let's go from there. So level D is a minor. So level E is a software. You can see it in the function, not in the consumer products. So there is no such thing. You write a code, develop a code, you write a code into it, you just put it up, and there is no requirement for it. You just want to have people that function check what is happening, and then that's out. Because the failure of that is not going to impact any life taking scenario there. That's the level E. And when it comes to level D, there is a little impact to the safety here, because if anything happens on that failure level, you're looking at injury or anything. So that's why that is there is an objective being defined for that. And there are there are total 26 objectives to be satisfied, and 2 of them with independence, which means the person who developed can be the verifier. So that's how they make dependencies. They need somebody outside the development area to come and inspect and verify and validate the product. One level up is level C. Here, if there is a failure in this, for an example, if there is an indication downfall, so it can be found by some other means. If there is a redundant system, the crew has to go through certain other equipments to understand where this is happening, and then they have to find the problem. So this is increasing the workload of the pilot, which is classified as level C. And level D is if there is a failure to the system, that's going to happen. This is going to contribute to injuries and serious impacts to the health. So in that scenario, what does is like the independency of validation is being forward. So they need in 69 objectives, 18 of them has to be done independently. So at least 2 people has to confirm that what is it. And the final level is the level A, which is classified as catastrophic. The reason behind if there is a failure of that it's mostly related to the life instance here. If any failure of that, the impact will cause loss of life. So that is high, and that's the highest standard what we have in the aerospace system. So you can see there is 71 objectives. However, 30 of them are not within. So that's the standard what we talked about it on different levels of failure, and what a failure can impact to a system and how it can be impacted to the life of the person who's in there. And and then now we'll move to the planning phase of it. So this is the D1s and FD are like the aerospace industry thrive based heavily on the planning phase. The majority of the time is spent on planning. So any software product we have or any PCB, board, or hardware we develop, this is highly most of the time cost. So the plan, there are 5 plans necessarily. The first one is the software PSAT. We call it as a plan for software specs of certification. This will say what we are going to do and how we are going to do and how we are going to satisfy the safety needs of each process. And then we'll have a software development plan, which is going to tell how the software development is going to happen, and what are the methodologies we are going to use, how the architecture is going to be, what is the development, what is going to be the environment, and how the configuration is going to let place, and what is the time frame of the project, and when and explain the schedule and expected. And then there is something called a software plan. This explains how the software is applied and how we are ensuring that the D1s and FDPs standards are met. And this speaking is the just go over there. To satisfy the needs. And the other two, I think one of the anything we write has to be in a configuration because it has to be reproduced at some point of time. Going back, these software, like I said, this software are it takes years of time, and also it stays active for 30+ years. So at some point, somebody wanted to go back and see what happened on that version. So there is a configuration which will say keep the data safe, and also also absolutely producing the scenario. At the configuration keeps it. Most of the general people follow like the subversion or other doors or other tools that are trigger tools. And then the last, but this is the pretty important thing, is the quality assurance. How we are making sure the product would be developed is has the quality to record for the standard. It will be inspected, and there is a quality check and audit that will happen for it in order to make sure that is happening. And then the final, and this is an optional one. So any tool or any software you use from the commercial market has to be qualified in order to be a part of this development program. So like any other additional tools are off-shelf market, or you internally develop tool, any tool, any kind of such has to be qualified before it can be used. So this talks about the plan order. And then when it comes to the now we move to the development phase where the development happens. There will be a requirement document, and then there will be a design document to explain the detail of how the design is going to happen. And somebody's going to write the source code, and we generate the executable object code out of it. That's a generic process. This is pretty familiar. Most of you would be familiar with this. And the verification side of it, because most of the time it is done independently, depending on the level of the software. So they'll have a verification cases, procedures, and then there will be a result. And the final review happens here. The final phase is where the configuration management, which talks about the software configuration index, lifecycle environment, and the qualification is recorded. What all these documents tells you is what is the version I used, and what document I used to generate this one, and where the documents are placed, and who's my software quality audit person, and is there an external audit happened, and how they checked it. All those steps are documented in this document. And then finally it comes to a software recommendation summary, which compromise of all the processes followed, and also it documents any deviation from the original. So these all documentations, so all this time what we talked about the document is this many documents, and is required to get the product out. In between this documentation phase, what is involved is there is going to be an XML. So that the auditor will come and check whether you are aligning with your plan, what your values talked about earlier. And there is going to be and then at the 50% of your development is complete, they come and check your development, the validation, whether the development is being happening as per the defined process, and also um, and in order to have the external person to validate the what you say. And SO83 is another credit which happens at the almost 80% of the validation has been developed, and they call it as a review to confirm that the process being again. And then SO4 is a final review. Here is where the external body delegated by the review committee is usually consists of a certified person defined as the for the reviewer, and also internal the company who's developing the product, and the developer and tech leads and everybody participates. And this designation, once the approval on this access is completed, the product is finally presented to the product. So this, following all this process, you finally can deploy your hardware, software to the hardware. Now, what it's not done yet. We just talked about documentation. Now, once the software has been qualified, it has been deployed to the hardware, and the hardware, the software has to go through and then run the specific process. What does this mean? Is like the aircraft has a different temperature variance when it is applied with a different altitude. So this chamber, whatever the hardware is going to be placed, will have a variation between 55 to negative 55 to 150 degrees temperature variation. And the test of the hardware will be sitting in the chamber with different temperature exposure, and they'll check the operational functionality of this product. However, it is able to perform to the requirement that there's different temperature levels. And that is on the temperature side of the outside. Vibration check, which can be done either vertically or horizontally. It's a constant vibration to see whether it can impact or minor impact this hardware. So what I'm checking? What are some of this test what we are trying to do right now, that the screening is basically we're trying to find, is there any loose part, is there any shoulder soldering that is not done properly, and all the connectors are intact. And then with all the changes happening in the environment, the hardware what we develop is not as it is needed without any training, and that's what we get up to this environmental stress. Once the product goes through the screen and we are satisfied with the needs of it, then the product finally go to an acceptance test procedure. This is a high level functional test just to make sure that they're working as intended, and then the product is ready to ship. It took me 30 minutes to explain just the high level process of the documentation process needs to be the product needs to be followed the development. And now you can correlate this with the time frame what I was talking about. To the developer project, it takes around 3 to 5 years, or sometimes it's like almost 10 years for the project. And why this is all because of the document complexity, documentations, and process. And by following all this process and safety of the product to the max. So that is the general process. Now I'm going to step into the software side of it, and how the software is done here. I'll dive in directly into, because we're not going to talk about the requirement capturing and other things of it, so I'll directly dive into the software. So you might see this architecture, like if you're familiar with any IoT or any embedded software. This is a standard architecture. However, this has a specific. This particular architecture is a patent architecture, and I just try to display as I see fit here. So if you see here, right, there is like it has more 4 and 5 major layers. So we'll start the application layer at the top, and within the repository layer. Application layer is where your software resides, and the repository is the placeholder where everybody can put data. So the data transfer between the application layer and data computer is the repository. The repository layer is what we generally talk about repository is. Repository is one person can write to it, but anybody can consume it. So like there's a one write and multiple. And this is by doing so, it is allowing that variable for something else. So that is a repository layer, and the data map layer is where all the data are identified and converted into the particular format that it needs to be virtual processor layer. So virtual processor layer is technically the layer which talks to the hardware. How we talk to the driver, how hardware is on those message formatting and the memory mapping. At the bottom, I put the hardware. Hardware could be your processor, your signal generator, or like your PWD or FPGA or whatever it is. Everything is considered as and all this layers, there is only one common processor, the executive. He is the executive or the that is the one which is going to schedule what process being involved. And then we do have a separate one as a common utility where your mathematical calculations or any general calculations or any service which we are using services and the processor related setup or like configuring IoT or SPI, services company. So those so the executive one has a startup mode and the second one is the prototype mode. So startup is like when the power is being applied to the board, the startup over initialize all the workflows and then making sure which keeps the rest of the alive and it just goes. So whatever I explained here, because it is not a class based, this is the best design, right? This is it's a time based execution. So how does data flow happen? Okay, this is how it the information is being read from the hardware. It's just one way out. And forward all the data in the data layer, inputs are forwarded, and then it put it on the register layer. And the process is like the application layer to talk to the repository, break over, and it does the action which is required by the server. Possibly opening a lab, right here, this we get put any command what is your application and then just this is explains that the project down to the given repository and it is being formatted in the data layer and virtual processor layer transfer the data to the hardware. That's a typical execution scenario, and this is not as simple as I put it here. It's not going to be a one way. The executive and this other runtime, the control goes to the executive to all the layers. Depends on how what happened, how it's working, and all the functions inside it. The data and shape and happen. When executive and the startup are the two people which can go technically up to all the layers without going through any mediators. That's why the executive layer is kept on the left side. So these people can access the application layer and the repository get information. So we talked about how the software architecture is being followed here, and like I said, remember this is not an RTOS based. This is a time based one. If the RTOS based structure is being kept, then the executive is replaced by the real time operating system, and then the schedule happens from there. But the right side of it remains the same. This is how we make the layer. And there are reasons why this layer is being made like this. We're going to talk about model-based engineering, and I just wanted to touch this a little bit before going there. You see this hardware layer. This layer, this is a real. Like if you check out this hardware layer out of this, the code can be functional without the actual hardware. We can simulate it and produce input and output to this. And why that important? So long and follow it. So what are we doing in the model-based system engineering here? Like I said, we talked about the architecture a little earlier, and how the software architecture is done. And now I'm just going to talk about one level up. What is model-based system engineering and why this is important to us, and how this is impacting this project. In the earlier days, the requirements are captured in a wording format, and it just needs to be interpreted by other people. How the software has to be returned, what is the intent of the requirement, and somebody else has to interpret it and write code design based on it. And it is leading to a lot of confusion. People, English is a foreign language. You can say the same thing in multiple ways, and you may not get to a common understanding between two people. You're trying to convey the same information. So that leads us to a lot of difference between what is the intent of the requirement and what could be visuals. So what is model-based engineering doing there to avoid that? Model-based engineering is where all the requirements are captured in the picture region. So there is not a lot of warnings involved. So it is simple, and it is pictorial, and it is straightforward. So you can easily see what it is and what are the decisions that are, what are the input coming inside, what are the decisions that are going to be made, and what are the output of it. So in the model-based engineering world, the requirements are returned picked up at pictures, and there's like around. So and you can actually see how the logic should work. That is avoiding a lot of confusions on the dependencies. But there is also an key aspect of model-based engineering is when the requirements are available. What it allows you to do, what it allows you to generate a code out of it. Not many people are into coding these days, even though we say that there are a lot of programming languages available, and we're writing codes here and there, but the reality is like the recent chances, if you are into this, you write the design of it. You spend most time designing what are the functionality there, how you want the to happen. So and also like once you make the decision right, design right, the tools are in such a way that like it can produce a code to satisfy the standards. So you don't need to sit and code with all certain coding standards write a code. And these model-based systems, like why this is in a way it is helping us in a faster ways. You can the output is great, but once the design is done, it's like you get the code, and the prototyping is really fast, and the testing of the code is very delivered. Right, be like if you see it, right, like when you are developing a hardware and the software will be developed in a parallel. Like there is a lean period between the hardware availability, the software availability, and then the time for integration is very. It's the integration time does not happen in the right time. So either hardware will be ready already, and the software is not done, or the hardware is not done yet, and you're ready with your software. You can't do anything with it. By model-based software engineering, what is happening is like the prototype is helping us much with you. So even before the hardware is ready, you have a model. You can validate your model. You can check the functionalities that are in the system, and then code also figure code. How this is helping us is like this kind of reduces our so it saves a lot of time. The analysis, what it is getting performed is being done very staged, and the problems are detected within it. the big thing about your 7IP is when there is a problem, if the problem is detected early in the life cycle, it's better and easy to fix. The later you find the problem, it is it's the fixing is like it is like a costly, and also it is you have to redo the process and the process. It is not effective. So people, so the design has a higher value in here. People tend to put more time on thinking how this works or what it does at the design and architecture. Leads has a lot of thought process behind it, right? So the early test and error detection is what is the key award of this model-based system engineering. Like what we do, we use Simulink usually, and there is another couple of tools. Just people are playing here. So let's say with Simulink is a MATLAB tool, and most of you would be familiar with the MATLAB. So the development, the models are captured in the Simulink, and the code is auto-generated once the simulation is done. And the code is like the model can execute by itself. These days, the embedded environment is such that you can all the processor and other stuff for the first can be simulated at the MATLAB, so you can generate and run the code. And why I wrote a faster execution here is in the real world, you cannot talk to the hardware directly. You have to have an emulator. You have to develop a test machine which can use input and output to the hardware. That time there is a latency being added between the hardware and the test equipment. So which is like the execution is not as fast as the normal scenario would happen. So there is a latency there, but with the model-based experience that is avoided. Just think, you write it, you run the code as fast as you can run, another computer can take, and then we test it out. That's how we are using model-based engineering here. I wanted to talk about a little bit on the neural network side because this is another latest trend happening right now. How neural network is helping and how we are using neural network in embedded systems. What we have there. So these neural networks, like as we speak, it is not yet approved to put it on the plate software, right? So what are we doing with that? So I did talk about the fuel system. I'll take that as an example here. The fuels are the tank. They have standard aircraft has 3 tanks, 2 tanks in the wing and 1 tank at the center. 1 tank is in the center of the body. So in order to calculate the tank structure and where to place the probe, where the sensors are placed and at what point you can keep the sensor to get an effective output out of this. You need to learn the tank structure and study the structure and place a probe so that you can read the tank quantity correctly. What we were doing actually is just play with the MATLAB. We just place different points and then keep the probes moving around and then try to find an ideal placeholder to compute the volume. But that is a time-consuming process. So we need to move the probe inch by inch and find a better location where it can do an optimal volume for you. So that is a really like if you're moving. Let's say that the tank is huge, and if you're moving inch by inch and trying to find an optimal spot, it takes months and years. Sometimes the tank study is something which is constantly going under the hood. But what is neural network doing? So neural network, we are training the network and placing the code in the stand study is done using neural network, and the neural network is placing the code in the optimal place, and it is training itself. We train the neural network get trained, and then just gives an output of what are the ideal places the sensor location should be kept to get the sensing proper quantity of it. And also it is we are using to calculate the profile table, what is the volume or what is the quantity and the kind of or when you are at a certain pitch and roll. And each stands will roughly have around 16 to 32 sensors. So if any of the sensors is not working, how the thing probe optimization is happening. The neural network is being deployed and it's getting trained and the output of the neural network is written and then it is being placed. This is saving a lot of time. Another concept is data analytics. So what are we doing with the data analytics part? So the soft architecture-wise, the data analytics architecture and the software architecture, embedded architecture are similar in nature. However, instead of the hardware, it talks to the IoT. So what we are doing is we are collecting the data from multiple test machines here, which is used for running. So the data is collected and it is put in. What are we doing with the data? So data is like we're collecting data on a daily basis. Like I should say, every time you have something happening, we upload the data. Huge amount of data, and before data, somebody was doing and analyzing the pattern and what is happening, is there anything these are done using Excel sheets or Python programming languages, data processing. But when data analytics, the new technology data analytics started, what has changed here is whether the concept of the process and find the data really quickly. The problem, the effort is to days to get a data and what is happening. Now it is happening instantly. And this is helping in the optimization of optimization and solution. So by doing this, displaying the data in a graphical manner, in another manner which makes sense for us to see what are the trends and how the data has been changing. Is there any loss of data and the back end and what production systems. So what is helping? What this is helping us is the future outcomes and customer care. How we are doing it, right? So basically, we are using a Python program. Not any other one. We're open the Python and the mechanism general. We collect the data, and then the data mining is happening, and the one data mining is happening. And we plot it. That's what I was saying. You plot it and see how the data is moving around, right? Which makes me looking for the program. And what is it helping? It's helping in identifying the failure. And when this happens, what could be the point of it? And this is helping us to the solution and to find how to fix this. All the inputs and scenarios are helping define the potential problem. Given the kind of sound of issues. And these are all the analytics point of view discussions. So on the board design, the board design part, what is changing in the PCB design right now? We're trending towards having a modular design approach now. So why modular design is important? Having a modular this is really helping me so the design is really in keeping things together, and also it is repeatable and configurable. And if the product, if the model is like, for an example, if the FPGA and the power supply and things that kept it in a single model together, it is allowing us to move across. So if the design is done for a program, and then the same board or same design which is used by another program or any other thing can be moved around. So the design is being moved between multiple programs. So by doing this, it's easy for us to upgrade from one platform to another one. And this is also very, very cost effective. you see as a program perspective. And by going modular, if there is a problem with the system, we can, we are just replacing a very bad piece of it. We don't need to replace the whole code and identifying the problem and isolating it from the other side of the possibility and just replacing one is really very big contribution to the saving initiative what we are doing here. And also what it does more than that, what it does is like the code concept remains the same. So moving your candidates between programs were much easier. And so and this is helping us with the reusability of this. So what I wanted to stress upon here is like it's not every time we are going on a modular architecture or every time we are going to an FPGA or a fabric-based design or a sourcing. No, we're not doing that. It is in the history or the study done around the idea when to use what. So we like I said, it's not a one solution for all. So we do have multiple solutions, and the base is where it doesn't go, we can go and identify. So I wanted to talk about the hardware here a little bit. So this is a hardware abstract layer. Concept what we are using is this is pretty much used because the process will get outdated in 10 years. So every 10 years the process is going 10 to 15 years, you don't get the same processor in the market, and it is getting outdated. So we have to change a piece of a chip processor, anything. A chip is getting replaced. We have to replace that only part, the rest of the domain active. In that aspect, we use hardware abstract layers. So this is allowing us to reuse the code if the microcontrollers are changing also. So we are able to use the same code. So reuse is increasing by along that. Then the further like we talk about the component isolation. So this is isolation is helping in not a different figure on and without affecting the other side. Then for the security side of it, we are going by the security boot or hardware-based security zone. So all the data, it's like the security is being incorporated in that. So like I was just saying, these are the concept like a system on chip. So when we have a impulse circuit design, if it is optimum, we'll put the design in there and then make assembly else design it for us and then bring the chip back in here, put it in the single place. So I have a better picture for you just to show you. So the embedded, I'll start with the embedded FPGA fabric, right? This is another thing we are doing right now, and this is a little expensive, but we pay based on the program we are doing. Why we are doing embedded FPGA is fabric is because it's just fast. And the processing, and it's not only like the data processing and the capturing, processing, and the decisions are made in there, and the output is only transferred to the concerned parties. That is why the embedded FPGA fabric is used. The other one what we are doing right now is the biggest systems are divided into multiple subsystems, and the subsystems are kept closer to the hardware so that the data can be collected quickly and decisions can be made right there, and then the communication have to go to the core processor rather than collect the data, send it to the core processor, that do the processing, mining, do the math calculations that producing output, which is time consuming and it is taking a lot of resources of the particular processor. So we are just allocating distributing it across, and only the crucial data are passed across the longest channel for decision making. So that. And then I wanted to talk a little bit about cybersecurity. So cybersecurity is new. relatively new to the aerospace industry because it was never part of, it never used any Wi-Fi or 5G or any other type of mechanism that can be reached externally. So it used to be black box, right? So now there's increasing cybersecurity steps. Cybersecurity is becoming a part of any software development. It is not only aerospace. Anything you work on at this time, it is a standard across. So the software standard requirements are being flowed on. So what are we doing in aerospace is like this architecture is adopting a zero trust architecture. So any input and access has to, any person with the access and how the access and exit points are being checked every time. We do the regular security audits, but also we're doing a penetration testing to see whether the path can be allowed to log in by only the necessary people. Anybody else can't reach. If you using automatic door, we are with the penetration testing will come to then we are trying to do the advanced threat detection and incident response. This is a piece of tool which is being put aside, and it is going to calculate the detected threat or anything abnormal is happening other than the defined process. It detects and then reports back to that. The biggest threat in cybersecurity is human. Even though we say that there's and every other all security measures are being calculated and put in the software, but the real threat is human. We need to be the human threat is high, and because we don't know the predictability it's not clearly defined, so it can happen anyway. So the training programs are advanced, and there's been very comprehensive training. This program was still established to say what can be done, what can be not, what cannot be done, and then if there is any measure, and if there is an incident and severe measures are taken, so the penalty is being at a higher level. So the training, the employees recognize the security of threat of it. So here we are going to talk a little bit. I want to go through this cybersecurity in the methods, how they're testing it done, right? Like the thread is like it's a thread can happen anyway. So we are modeling some of the threads and injecting to the system and see how the system is calculating and how they're responding to the thread. We do this security requirement testing. Every system has a security requirement associated with cybersecurity that is being tested thoroughly. So also the static code analysis is a big thing. But also we do certain penetration testing, mitigation, obvious testing. Like you do come up with the scenarios which is not possible to track, but still we try to generate the scenarios and throw to the hardware and see whether how it will respond to this issues and understand. A lot of analysis and testing is done to make sure that it is safety, but you know what, there is still vulnerabilities. The tests or anything is being found is only to the known vulnerabilities still there. Every day we learn and we go and handle those issues. So we come to our new topic. This is another one called testing. Okay. What is testing? Let's try it again. So the testing is a system usually that is developed to talk to the hardware, to the embedded hardware, and simulate input and output necessary to connect to the box. So this is an illustration of how it looks like. I just put a random section from the internet. You see, this is a general test equipment, which has a CPU, a computer, and then other hardwares involved in it, like for every protocol we use, and inputs and outputs for the software. So what we do with this test equipment? Test equipments are this is another computer where that is modeled with it's modeled to talk to the actual hardware. So how this is happening? So if you see here, there are two pictures I put. One is the actual the test weight, which is a familiar platform. So it contains all the necessary hardware and hardware and wires to talk to the test. And then there is another picture on the right side which explains, which shows a little bit of software what we use to develop to drive those or drive or simulate those input scenarios from a computer. Here, the picture what I have put in there is a 1550 model. It is a 1550 standard protocol across planets. So this protocol is like what it does. It's like a translate how the data transfer is happening between this test equipment to the hardware. Let's say the unit and the test are the embedded software is using the protocol. You need to provide input to the hardware. You cannot there should be another system to simulate input, and this test equipment acts as that simulator to give all the input. And the test equipment is developed here using a lab software. The test and mostly the test is this test equipment is developed using NI softwares. Here we are the snapshot what I put in here is a lab view. You can see this software is a pictorial, similar to a simulation, which is a pictorial representation of the code. So how it looks like that and what's the development is happening. Let's say you have a certain display input, print outputs, and any other protocol inputs, messages, analog, and anything. You can just develop simulate those inputs here. And this panels, whatever it is, it's called the VI panels. You have multiple. You can have multiple VI panels like that. These panels will help us in setting the input and also reading the output out of the box. This will be input and output. This being the hardware, the hardware here. It's see. So this is a black box. So this black box does not know anything. We need an input to get it forward. This doesn't by ideally you keep this system by itself. It's not going to do anything. It's just a black box which has two ports in it, and if it is powered on, then collect input and make decisions. Our input and give you an output. So to get this one powered on, I can also give all the inputs to this black box. This test equipment is used. The test equipment will power on this hardware and also produce all the input to it. When the inputs are passed to this, and based on the input parameter where you're passing it, you can have an output generated over this box for mass condition, and it can be displayed here. This is what the test equipment is doing, right? So I just explained about what we keep doing and what are the systems and how what is the process, how we are doing model-based engineering, data analytics, cybersecurity, and all this stuff. But now we come to the core of it. Fuel system, right? I could have put this first, but I just wanted to explain the process and other stuff before we go and deep dive into the system. How is the system work? You see here, I put two pictures. One is on two airplanes. They look different. You can spot the differences being this one. This is the external force. And these wings, the wings are filled with fuels. You can have, you can see there is an inner tank and outer tank and ventilation tank, and the left and right has the same. And there is a center tank at the bottom. Some aircraft have auxiliary tanks, which can be on your belly of the aircraft. So they have more tanks in it. So what the fuel system does is basically, if you place a sensor on the wings, and based on the geometry of the tank, the data, the neural network study what we explained earlier, which calculates the sensor positions. And based on the calculated position, the sensors are placed. So each wing tank here can have a sensor between 16 to 32 sensors. And the center tank will have 4 or 5 because center tank is a tank which does not change in shape. But these two wing tanks, the shape will change when you are in air or when they're on the ground in air, and because of the pitch and roll, there is a deflection to the wing tank, so that changes. So the number of probes kept on the wing tanks are higher in nature to accommodate that. And the wing tanks are the one you can see 2 engines here. The basic purpose of these tanks, fuels, and everything is to feed these engines go, right? And how the transfer happens is using a pumps and valves between the center and the wing tank. The pump, the pump helps to pump the fuel from the center tank, and based on which tanks needed the fuel, the valve will be open, and the valve, the fuel goes from one to another. And if there is an imbalance, for an example, let's say one tank, left side tank has used more of its fuel, and you're going imbalance. What happens is the flight goes in a tilt mode, right? So in order to balance the airplane, the transfer happens between those 2 wing tanks to keep it stable. In this picture, you can see also hose here. This is what it is called, hose. This is a military aircraft. It's not a commercial. So what this does is, when this airplane can fuel another airplane during the air, in the air. So there will be a hose here on the fighter aircraft. They come back here, and then they want to do a spare connector. The transfer can happen through this to the other tank while the aircraft is in the air. This is a commercial. Any commercial airplane, general airplanes has this structure of it: 2 wing tanks and then 1 center tank. They also have some vent tank at the end. This is a structure for the. So how the fuels are measured? The fuels are just currently measured as a capacitance-based probe. What is a capacitance-based measurement? So capacitance probes are coaxial sensors. So if you see this as I try to be. Consider this as a tube, and there is an inner layer that you. So this is a capacitance-based probe. So what happens is that's pretty much how the probe looks like. Sorry. So this is the sensors. It's so these probes are excited by external voltages. Once these probes are in place in tank, depends on the nature of the fuel here. Just going to calculate how much this probe is covered, and this point is being taken, and this point will be computed against the volume of the tank, placeholder where the sensor location, and then how much this is covered based on this, and an algorithm is being put on to calculate the current flow to this probe. What is the probe around this here? To be computed, and then it will be reported. This is how the current capacitance probes are there. So any variation in this will show you the flow height and different altitude levels, if the pitch and roll. So pitch means going up, roll is a tilt. So if the pitch is up, let's say the nose of the curve is up, then fuel tends to be on the backside of it. So you have to place probe in to calculate where the fuel is, and based on the pitch and roll, play the major role in calculating the volume. Yep, that's a capacitance probe here. It's been inserted, and the capacitance change in the capacitance of this has been computed, and then each capacitance has been put in a section, and this is going to give you the volume of the current tank. It's not only you calculated the capacitance of the probe right now, which has been just going to give you how much it is covered. That's not enough for you to compute the volume. You need to know the compensator. You need to know the dielectric of to understand what is the volume of it. So the dielectric will be calculated, and the dielectric will be used to convert the like we call that as a compensators. So that we give the dielectric of the field. So that once the dielectric is calculated, the probe, the probe level, the formula will like you just multiply that with the dielectric, and then you get it, the dielectric will give you density, and the probe will give you the volume, and volume divided by you get the mass out of it. So and then there is also something called low level sensors. The sensors are the level sensors are similar to a capacitance probe, which is kept in different levels of the tank. There are two major reasons, major purpose of this. One is to indicate whether the probe is like whether you have enough fuel and whether you have reached the limit of the fuel, low level limit of fuel, or you are above the high level limit. So the low level limit is when you are wanted the alarm saying, okay, there is not enough fuel to be there. The high level limit is just to indicate that your tank is almost full, not full anymore into the system. So how the fuel is being filled in this, there is something called a refuel panel. So the fuel is transferred to that. You can do a multiple way of filling. One is you can fill tank by tank, but that doesn't happen every time. So there is another thing called automatic refueling. You just set the quantity what you want for the aircraft. The software calculates the computer, it computes how much fuel it is already in the tank, and also it just distributed to fit what are the quantities associated with that. So it calculates the distribution formula and where the fuel has to go in such a way that the tank can hold all the fuel when you're trying to pump inside. Can we just talk about this capacitance probe? Yeah, this capacitance is currently used in most of the airlines. Talk about Airbus, Boeing, or Bombardier. I think in airline they capacitance probe, base probe right now. Where is it heading towards? Right, there's a Boeing right now is the only airline just using an ultrasonic sensor. So this is the ultrasonic sensor is a fiber optic sensor. They have put the fiber optics and sensor inside. And what it is doing, why they are referred to the two purposes. One is it's lighter than weight. Second, there is much excitation to the ground. You don't want to have a power to the fuel tank, right? So they're doing that. Those are the two reasons why this ultrasonic sensors are used. Where is the current fuel aviation is going? Airbus is working on liquid hydrogen at this point. So instead of having a normal jet A or jet B fuel, the liquid nitrogen section is being developed. And the Airbus is leaning towards liquid nitrogen. Right now they are going on a zero fuel. They wanted to use liquid hydrogen. And this feasibility study is being done, and we do have a proof of concept and the stuff, but To see this in the reality, this is going to be another things. However, Airbus wanted to start next year, so probably another 3-4 years next year we could have an airplane flying now. Boeing is, like I said, Boeing has used some ultrasonic sensors. However, they are leaning towards an optical-based pressure-based gauging. So what it does optical-based pressure sensor does is it does calculate the time, but the optical it's a very thin, and the hardware what we have developed for the optical pressure-based gauging it's in the size of a 25 paise coin. Then MEMS technology is being used, and it is minimized to a core, and then it just mounted to the tank. You will have 20 or 25 output mounted into the same and it's very tiny. Also, it's very lightweight and weight is important. This optical product pressure-based gauging is getting it mounted, but to be on the air, I don't think they're going to happen. Right, putting it 5 seconds to go on place. So that's pretty much how the fuel system is working. Stuff, and I can go here, but it's so this is this like I was just talking about primarily on a Facebook, right? How is the industry standards across, right? So there's a price study. We talked about aerospace, which is B170. They have a DAL levels. The safety of the safety is the reason and what level is the appropriate safety. So the first thing is when you are following video on the MFP, the tracing is very important to find bi-directional traceability. The output will be traced all the way down to the code, and the code object code, and the object code will be traced all the way to your requirement. So that is being achieved, and also the object code analysis is it's done only at the level software. Object code analysis is making sure your compiler is not introducing any command than what we intended to do. So every compilation command, right? It's the object level. Every compiler will go on and every command has to have flexibility and to be used for any purpose. So where is aerospace industry going right now? Is that they are trending more towards the model-based development. And also neural networking. Still, it is in the early stage of it. We don't. There is no approved process as standard as such. Because of model-based is development is huge, and system-based model-based system engineering is the trend of this. So if you take the same and contrast with the automobile industry is has the similar standards and other stuff, but what is different here is they mass produce things, right? And they don't want the fancy, safe, the temperature. You don't need weight sample to minus 50 to 150 temperature. They need something to work with the normal temperature, and a little bit of bandwidth here and there, right? It's not that aggressively tested, and so they are quite confusing it. So it just go, rapid prototyping happens, and we will see a new car every 3 years in market. Every 5 years you get a new model. And currently what they're doing, what is their trend right now is they're leaning towards the AI-based applications. Because if you see that AI is all taking most of the technology use data. And here in the US, you can see cars driving by. There are a few companies who actually cars on the road, and you can just hop on, and it's a taxi. So you hop on the taxi to take you to where you are instructed to go. It is completely autonomous. Like it drives it like how people ride. And this is a locomotives. This is nothing but the train. They have a similar and very stringent standard similar to aerospace. They go with the software. It's like differences like software level from S0 to S4. This is basically because of the the derailing of the plane accident. This is all defining the train. So how that standard, what they are following and how they are doing it. So here, they want independency, almost equivalent to the aerospace industry. It is the independence is mandate, and you have to have a different person other than who developed the design to verify the product. The same person can do the same. The designer cannot be a verifier. Verifier can do the same. They are two independent roles, and quality things are involved in it. So they are morely focused on independency just to make sure the standards are being met. They are now the automobile and locomotives are also one of the two qualified, which is not there earlier. And now this is the another one I wanted to compare against is devices. Medical devices is it's regulated now. They have a regulatory body because the medical device systems are being it's done very, very quickly because it's a consumer product. It does not get involved unless these products are used on the body for measurements. Like say if you take a pressure measurement or ECG and other equipments are developed at a faster rate and developed this rapid. We don't have the single substations on the safety side of it. It's all exploding. So we see it as a general aerospace lean on traceability now to code verification. Like the automobile, it is hardware and software architecture. Locomotive, they are all independent software verification and validation. So if you hear most of the time the verification is huge on locomotive and aerospace, the reason being the verification takes 60 to 70% of the whole program budget is spent on verification, just to make sure that software is safe. Something. That's straight example. The medical is the risk analysis and post-market monitoring from the established specification. So what I wanted to say here as a summary is, right, we talked about all the industries, standards, and other stuff and other practices. What is common across? When we talk about embedded, the programming language is pretty common across all the four. Any other embedded systems I work with, it's all programming is common. The process of communication, like you can take I2C, RSPI, any other internal CAN or UART, all this protocols, it can that's you. And then the protocols. Let's talk about protocols here for a minute. Protocols, like you say, CAN for automobile industry, CAN is used in the aerospace, CAN is used in the locomotive. So these are general protocol. CAN 1553 is predominantly used as a military standard protocol. It is a passive transferring protocol at this point. That's used in the aerospace. Then you have ARINC 664, ARINC AFDX. UART, all this communication concept, it is across everywhere. It's not focused on one particular domain. This is across. And then architecture. I'm sure you have gone through the certain presentations, talked about IoT architecture, the software architecture, and the architecture. The architecture is still the same. The standard practice and the process makes it rigorous and time consuming. But otherwise, these are the core concept of embedded engineering remains the same. With that, I think I'm going to conclude my presentation here, and I'm open for questions. If you guys have any questions or anything, please go ahead.
Okay, sir. Participants, if you have any queries, you can raise it now.
Please text it in the chat box.
Sir, let's conclude now. There is no more questions.
Oh, thank you so much, ma'am, for the opportunity.
Thank you, sir. Sir, I hope now all the participants have enriched your knowledge in various emerging technologies in embedded system in a broader sense, especially the challenges faced in aircraft fuel system, in industry standards, etc. Thank you, sir. Thank you, sir, for the valuable, more informative and insightful session on emerging technologies in embedded systems. Thank you, sir.
Right.
We request all the participants to fill the feedback and attendance form which is shared in the chat box. Dear participants, validity section is to be started. So participants, stay tuned.
Ma'am, our honorable director sir has joined, so you can initiate the
Okay.
proceedings, ma'am.
Okay, sir. Okay, sir. Good evening to one and all present here. A warm welcome to all for the validity section. Sir, 1 minute. Okay, let's start. Good evening to one and all present here. A warm welcome to all for the validity ceremony. As we have come to the conclusion of this AICT sponsored, adult sponsored 6 days online faculty development program, I request few participants to share your feedbacks.
Ma'am, can we unmute everyone, ma'am?
Yes, sir. Yes.
Participants, you have been unmuted, so please.
Good evening, ma'am.
Good evening.
Good evening, all of you. It's a very great opportunity to get that information about IoT and embedded system. It was very nice session. All the faculties who taught us, it was very good and very informative. We will definitely going to implement in our institution for teaching one.
Ma'am,
Thank you
can
very
you
much.
please share about yourselves, ma'am?
Yes, I'm Professor Ranu Sahu from Baderia Global Institute of Engineering and Management, Jabalpur, Madhya Pradesh.
Thank you,
I'm
ma'am.
having, yes, sir.
Yes, ma'am, please proceed.
Yes, I am 22 years of experience, sir, and I am also teaching IoT from last 3 years. So it was very great opportunity to get all others information, real-time applications and all. Thank you so much. That was very nice session.
Thank you, ma'am.
Thank you, ma'am.
Any other participants?
Hello.
So good evening, sir.
Good evening, ma'am.
I am Sharmi Roy, Assistant Professor, Department of EC from Arya College of Engineering, Artur. So this 6-day online adult faculty development program has been a very useful session for us. So we have been handling embedded systems and IoT paper also. And so this is very useful for the research scholars as well as the faculty members.
So very well done for the conducting such a fruitful session for us. We are expecting more sessions like this. Thank you.
Thank you, ma'am.
Good evening, ma'am.
Good evening, ma'am.
I'm Aarti Vasam from Solapur. I'm teaching, I'm actually working in A.G. Patil Institute of Technology currently. So I'm handling IoT subjects since last 2 years. So there was some problem for communication, that wireless communication and all. So I got very good knowledge in this 6 days FDPs. And I'm planning to do some PhD research work in IoT itself. So it's been very helpful for me for whatever the session you have conducted. So in future also, we'll see the further we will see the same FDPs from you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Good evening, ma'am.
Good evening, sir.
Yeah, my name is Tirmurugan from Assistant Professor CSC in Erur Sengundar Engineering College. For 6 days FTP, I am studied and attended the IoT and embedded system. It is useful for doing PhD in IoT. Thank you for a wonderful section. Thank you, ma'am.
Thank you, sir.
Good evening, ma'am.
Good
This
evening,
side
ma'am.
Maninder. I'm from Riyadh Bhara University, Mohali, and I'm working as assistant professor in EC department here. First of all, I would like to thank you for organizing such an insightful and well-structured FDP. I truly appreciate the efforts and dedication and well planning of this program. And I'm teaching this subject since 2024, and I have got an enormous amount of knowledge from this FDP. I'm very thankful to you for organizing this kind of FDP. Thank you so very much.
Thank you, ma'am.
Evelyn ma'am, shall we start the proceedings, ma'am?
Okay, sir. Thank you for your valuable feedback. We are grateful for your active support and participation throughout the session. Now I request our esteemed director, Engineer K.S. Dharan Surat, to express his valuable thoughts.
Thank you, ma'am. So good evening to one and all present here. So I'm really happy that everyone has participated very effectively, and the feedback which I am hearing is really happy for us. First of all, I would like to thank AICT and Atal for providing and sponsoring this FTP 6 days online FTP, as well as all the department of EC staffs, faculties, deans of Arunachala College of Engineering for Women to make this FTP happen in a very systematic and a dynamic way. Also, I would like to thank the resource persons who all are actively participated and sharing their knowledge to all the faculties throughout India, and mainly all the faculties. I'm really happy that you have participated in a very good manner and you have gained some knowledge out of it. So really happy for that. Also, since we are a #1 women's engineering college in Tamil Nadu, based on academic ranking, we are also focusing on the skill development as well. So for skill development, currently in last week, we have conducted a wonderful AI colloquium, which is a AI simulation conclave kind of thing, a boot camp where all the students have organized it. So we didn't step up, only the students have organized it. Students have invited the guests and everything they have conducted, and we have completely successfully completed the event as well. So resource person from industry has given the boot camp training to the students. Also, we are also planning for a hackathon. So that is a all India women's only hackathon, which is She Hacks, which will be conducted by next week. All over students from all over India, as well as from Tamil Nadu, in Kerala, Andhra, Jaipur, everywhere the students are coming. We are really happy to initiate it. So I wish all the faculty to support us in the forthcoming events of like the She Hacks or hackathon events. to encourage your students to participate. So skill development is mandatory. That's what we are in this era, and we are planning this FDP as well. So once again, I would like to thank everyone for participating. And forthcoming years, forthcoming academic year or next summer also, we will try to have more FDPs to all the faculties to improve our skills. So wishing this event a grand success, and this is a grand success for us. Thank you for the opportunity. Thank you. Thank you, ma'am.
Thank you, sir. Evelyn, ma'am. Dear participants, hold still. Our assessment links will be shared. Evelyn, ma'am.
Yes, sir. Thank you, sir, for your valuable words. Now it's time to propose vote of thanks. First and foremost, I would like to thank the Lord Almighty for granting us good health, clarity of thoughts, and opportunity to come together in the spirit of learning and collaboration. Next, I express our sincere gratitude to AICTE, Atal Academy, for providing us this valuable opportunity and for their continuous support in promoting quality faculty development initiatives. We express our profound gratitude to all the eminent resource persons who generously shared their expertise, insights, and real-time experiences. Their informative and inspiring sessions have truly enriched the knowledge and skills of all the participants. Thank you all. We extend our heartfelt thanks to our Honorable Chairman, Dr. T. Krishnaswamy, for his constant support, encouragement, and guidance, without which this program would not have been possible. Thank you, sir. Our heartfelt thanks to respected Principal Dr. S. Joseph Jauhar for his meticulous planning, dedication, and teamwork in making this program a smooth and successful one. Thank you, sir. We extend our heartfelt thanks to our esteemed Director, Engineer K.S. Darun Surat, for his enthusiastic involvement, guidance, and encouragement towards organizing the program. Thank you, sir. Next, we would like to express our sincere thanks to Vice Chairman, Ms. M.L. Suni, Director N. Meena Zenith, for their constant support and encouragement towards this program. Thank you, ma'am. We express our deep sense of gratitude to our Dean Research and Innovation, Dr. S.S. Winsley, and Dean Academics, Dr. Dev Ornevler, co-coordinator of this program, for their valuable guidance, motivation throughout the successful planning and execution of this faculty development program. Thank you, sir. We express our sincere thanks to respected head of the department, Dr. E.P. Kannan, for his constant support throughout this program. Thank you, sir. Our sincere appreciation goes to the organizing committee, Dr. G. Starlit Beulah, faculties of EC department, Amarnath sir, Palani Dev sir, for their meticulous efforts and supports throughout this program. Thank you all. A special thanks to all the participants from various institutions across the country for their active involvement, enthusiastic participation, thoughtful questions, and disciplined presence made this FDP lively and meaningful. With these words, I once again thank everyone contributed directly or indirectly to the grand success of this faculty development program. Thank you, one and all. Thank you.
Ma'am, you can announce the next event,
Yes.
ma'am.
Instruction to participants. So participants, now you can log in into your Atal portal and complete your assessment exam. And then you have to fill the feedback form in the same portal. After completing the feedback form, you can able to receive your certificates. Kindly download the certificates from your laptop or PC. In order to avoid server errors, I'm uploading the assessment link in your WhatsApp group also. Kindly go through it. Okay, thank you. Sir,
Yes, ma'am.
wind up.
Shall we wind up, ma'am?
Yes, sir.
Till the assessment is completed, we should be there.
Okay, let me sit for
Let
5.
us mute and let us hold, ma'am. Let them
Okay,
complete
sir.
the proceedings.
Okay, sir.
Hello, ma'am. Hello.
Sir, yes, sir.
Yes, sir. Is there any sequence means first assessment or first feedback is there? What we have to do first, sir?
Evelyn, ma'am.
Kindly enter into the Atal portal and do your assessment exam.
Ma'am,
And,
Or
I'm
you can
asking,
try this. I am sending the link. You can try this.
ma'am, first we have to complete assessment. Then after we have to submit feedback, no, ma'am.
Everything okay only, sir. You can complete the feedback and then assessment. Everything okay.
Okay, ma'am. Thank you. Thank you.
Okay.
Evelyn, ma'am,
Hello.
is it going to be activated just now or it will take some time?
Yes, sir. It is in the link. You can click
Hello,
it.
ma'am. Yes.
Yes,
Can I take the assessment in the FD Atal portal?
yes, ma'am. Sure.
I will. Okay, okay, okay.
I will be also sharing in the group. Here also I have shared it. I will be sharing in the group also, ma'am. Kindly wait.
Yeah. Is there any time limit for the
Yes, ma'am,
assessment?
up to 9 o'clock.
Okay, okay, ma'am. Thank you.
Ma'am, if you give the exam from this form, then is there any need to do the same from Atal portal also?
No, sir. But you have to fill the feedback from Atal portal.
Okay, okay, ma'am, fine.
Okay, sir. Sir, many of them have received their certificates. So let
Is
us
it so,
leave.
ma'am?
Yes, sir.
If that is the case, if there is
Oh,
no
yes,
necessity,
sir.
we can leave, ma'am.
Yes, sir. If they are entering in that Google form, I will putting the entry. After that, they will be receiving their certificates.
Okay, right, ma'am. Right.
Okay, sir. Then we shall leave.
Okay, ma'am.
Thank you all participants.